Hello everyone, my name is Abhishek and welcome back to my channel. And welcome to day 1 of Terraform Zero to Hero series. Before I get started, for all the new subscribers, let me tell you that this is a 7 days of Terraform Zero to Hero series. I call it Zero to Hero because there are no prerequisites and you don't need to have any prior knowledge of Terraform to get started with this. And what exactly are you going to learn in this series? Don't worry, that complete information is already available in the GitHub repository that I'm sharing. The repository name is Terraform Zero to Hero. It is uploaded in my organization called I am Veeramalla. You can also find that link in the description. So if you scroll down, you will find a file called readme.md. And in this file, I have provided information what you are going to learn on day 1, day 2 till day 7. Everything is available. Let's say you want to understand even in a better way what you are going to get from this series. You can also watch video called day 0. It is already published. It is available in the playlist called Terraform Zero to Hero on my channel, or you can use the link in the description where I've spent some 30 minutes to explain about the course syllabus. Okay, so I think I've explained enough about what this series is, and now I hope everyone understands what you are going to get from this series. Now let's get started with today's episode, that is day 1. As part of day 1, we will understand what is infrastructure as code. We will try to see how and why Terraform fits into the concept of infrastructure as code. After that, I will explain why Terraform is one of the most required skills for a DevOps and cloud engineer. These days, everyone is asking Terraform as a required skill. So we'll try to understand why that is happening. And after that, I'll explain you how to install Terraform on macOS, Linux, and Windows. And specially for this section, there is a surprise. So please wait for it. For people who don't have laptops, or for people who don't have enough resources on their laptops, I'm going to provide a solution. So that's going to be really cool. So please wait for that. And after that, I'm going to show you how to set up Terraform for AWS, because this series we are going to focus mostly on the AWS infrastructure. So I'll show you how to authenticate to AWS using Terraform, and that is same thing that we are going to use throughout the series. So as part of day 1, it is very much required for me to explain how to set up Terraform for AWS. Then we will move towards learning how to write your first Terraform code. As part of that, we will see how to launch an EC2 instance, that is how to create a virtual machine on AWS platform using Terraform. And while doing this, we will also learn about the Terraform lifecycle. Don't worry about that. Like I told you, there are no prerequisites. I'll take enough time to explain about each and everything that we are going to learn today. Finally, I'll just provide some basics about Terraform Statefile, but this is very basic information because we have a dedicated video for Terraform Statefile. So let's say that you are a DevOps engineer and you are given a very simple task to create S3 bucket on the AWS platform. So obviously, the very simple way of doing it is you can go to AWS console, provide your username and password, authenticate with AWS, and search for S3 service. Go there, provide a bunch of details such as what should be the name of your S3 bucket, should you enable or disable the public access, do you need versioned or unversioned. You will provide bunch of details, and finally you will get a S3 bucket. Let's say probably it takes 2 minutes of time. So you might be thinking that, okay, it's perfect. But what if you get similar requests from multiple teams? Let's say you got similar requests to create S3 bucket from 100 teams. So the number of minutes that you're taking is multiplied by the number of requests. So obviously, I think everyone knows here, to solve this problem, what you will do is instead of manually creating resources on AWS through the user interface, you will follow a programmatic approach. Okay. what you will do is you will follow a programmatic approach where you can use either the AWS CLI, or through your scripting knowledge, you can interact with AWS APIs. So every service in AWS, whether it can be S3, it can be EC2, so the AWS team will develop a API. Now, API, if you don't know what is an API, you can simply understand that if you have knowledge of Python, or if you have knowledge of Shell or any programming language, you can talk to the AWS services programmatically through the APIs. That means you can make calls to AWS. Instead of logging into AWS, you can simply make a call to that particular AWS service through your program. Okay. So this is a very simple definition of API. Now you can either use CLI or API and write your code one single time. Let's say you want to write it in Python. So you can use Boto3 or you can use the AWS CLI. Anyways, you will write some code to create S3 bucket. And now whether it can be 100, 1,000, all that you will tell the team is, okay, there is a script here. Either you run it, or if you don't have access, I will run it, and in fraction of seconds, your S3 bucket is created, or in seconds, your S3 bucket is created, right? So this way, what you are trying to do is you are reducing your effort. But the main problem is that you need to have programming knowledge, right? So the request here is very simple, that you just need to create a S3 bucket. But what if you are asked to create VPC plus VPC configuration, everything related to VPC, plus you are asked to create an EC2 instance, and this EC2 instance has to be highly available, and you need to create an S3 bucket as an endpoint to the VPC, right? So if you want to do all of these things, you need to have good programming knowledge. So the cloud providers like AWS, what they said is, okay, DevOps engineers, some of you might not have good programming knowledge. So what we can do is we will do the heavy lifting, and we will introduce something called as cloud formation templates. And in the cloud formation templates, what you need to do is, it is just a template where you can write this template either in JSON or YAML. Now, most of the people in the industry, they already know JSON and YAML because it's a standard templating language to share the outputs, or to provide input to any tools. Already we use JSON or YAML. So CFT, that is cloud formation templates, will allow you to write your infrastructure. Watch carefully what I'm telling. They will allow you to write your infrastructure as code. So you will just write that I need VPC, I need S3, I need etc, etc, some configuration that is required, right? In terms of a templating language, that is in JSON or YAML. CFT has a very good documentation. You can just go to the CFT documentation and see how to write that in a JSON YAML format that AWS understands, right? So this way you are writing your infrastructure as code. This code can be shell scripting, this code can be Python coding, or this code can be any of the templates such as YAML or JSON. Because you are not doing it manually through the UI, you have automated that. So that automation, again I'm repeating, it can be a simple template that is in JSON YAML format, right? Or it can be in any scripting mechanism. Because you are writing your infrastructure as a code, we call these kind of tools as infrastructure as code. Okay, so these kind of tools are called infrastructure as code. Now there are so many infrastructure as code tools that are available in market. For example, we just discussed for AWS cloud formation templates. Okay, for AWS cloud formation template is an infrastructure as code tool. Let's say you are working with Azure. Azure has similar kind of mechanism where you just need to write your infrastructure in the YAML format or the JSON format that Azure Resource Manager understands. Okay. So Azure people also have created a infrastructure as code tool, which is called as Azure Resource Manager. If you just go to your Azure Resource Manager documentation, you will understand how to provide this JSON syntax, how to provide this YAML syntax that this resource manager understands. And whatever you put here, let's say you need a VM in Azure, or you need a AKS cluster in Azure, or you need blob storage in Azure. So just put it in the format that resource manager understands, and it will make a request to Azure and it will create you the infrastructure. Let's say you're on OpenStack. So OpenStack also has something similar called heat templates. So there are multiple tools in the market. For each provider, the developers of that provider, for AWS, the AWS team has created CloudFormation templates. For Azure, Azure team has created Resource Manager. For OpenStack, of course, there is something called heat templates that OpenStack team has developed. Now, the problem is that, now you might be thinking, Abhishek, perfect, I understood what is advantage of CloudFormation templates, what is advantage of basically IAC tools. They are super useful. I understood about it. But now why Terraform? Right? When you have all of these tools, which is automating the infrastructure, which is reducing the efforts of DevOps engineers, now why should I learn Terraform? The answer here is very, very simple. So as a DevOps engineers or as people who create infrastructure, you might have to deal with a lot of tools. So let's say in your organization, you are using AWS, and one of the project in your organization is using Azure. You move to a different company where they are using OpenStack. Some other company, they are using GCP. As a DevOps engineer, how many tools would you learn, right? Or for any person who is trying to automate infrastructure, they cannot learn so many tools, right? So Terraform saw this problem. You cannot learn CloudFormation template, you cannot learn resource manager. Of course, they have very good documentation, but still, as a DevOps engineer, it gets very difficult for you to learn all of these things. And to add that, some of these tools might also require some scripting knowledge. So what Terraform said is, okay, don't worry, we will come up with a universal approach. That means you don't need to learn all of these tools, just learn Terraform. Okay, and tell Terraform what provider you require, or where do you want to automate the infrastructure. Do you want to automate infrastructure on AWS? Tell me. Do you want to automate infrastructure on Azure? Provide that. Do you want to automate infrastructure on GCP? Don't worry, I can do that. So Terraform is very, very important, because irrespective of the provider that you are using, right? If you have knowledge on just Terraform, that is enough. You need to learn how to write Terraform templating language, which is called as HashiCorp templating language, or it is also called HashiCorp language. And if you just know this one, which we are going to learn in this series, in this entire series, I'll tell you some shortcuts. I'll tell you how to write this HCL language, right? I am going to provide you some IDE shortcuts, what plugins to use, and all of these things, which will make you to learn Terraform in a very simple way. And by learning Terraform, you don't have to worry about all of these tools like CloudFormation templates, Resource Manager, Heat templates, etc., etc. Now that's the reason why Terraform has become a mandatory skill for DevOps and cloud engineers. And the other reason is that these days people are heavily moving their heavily increasing their infrastructure to match the customer needs, or to move rapidly towards scalable infrastructure or highly available infrastructure. Now, if you want to create highly available infrastructure, doing it manually is not possible, and learning all of these tools is not possible. So again, the only option that is left is Terraform. Now you might be thinking, but Abhishek, are there no competitors to Terraform? Of course there are competitors. You have tools like Crossplane, you have Pulumi, so many tools, Crossplane, sorry. So many tools are available in the market, but Terraform is the pioneer. Terraform has started this practice of universal approach where one Terraform using the concept of API as code internally. You don't need to understand how Terraform uses this API code as concept, API as code as concept, but irrespective of the cloud provider, because it uses this approach called API as code, it will directly talk to the provider APIs. So whatever you are writing in the HCL language, Terraform will see what is your requirement. If you want to talk to AWS, this HCL templates are converted to the AWS APIs. If you say Terraform that no, I want to automate infrastructure on Azure, the HCL code that you have written will be converted to the Azure APIs. And Terraform will apply these APIs and create your infrastructure. That's why it is called API as code as well. This is kind of an interview question or something for you to understand in detail. But going back, there are alternatives, but Terraform has started this entire thing. So it has a very good community, right? So Terraform has a huge community. It is started by HashiCorp. Of course, there are some recent things that are going on that Terraform is no longer open source. They have changed their licensing mechanism. But for now, as an end user, you are not impacted. Your organization can still continue to use Terraform if they are using Terraform to create infrastructure. Only the DevOps as service tools companies are impacted. Let's not go into that because I'll anyways cover that entire thing in some other video. I've explained that in one of the previous videos, but in this series as well, I'll try to cover that somewhere. For now, I think you understood the concept. There are alternatives. Crossplane is a very good emerging alternative, but Terraform has the largest market as of now. The other tools are not as matured as Terraform. They are not as simple as Terraform. That's why Terraform is still the bigger one in the market. That's why many people are asking Terraform during your interviews. Now let's see how to install Terraform. So the installation of Terraform is pretty straightforward. You have a Windows machine or Linux machine or a Mac, anything, the installation is very simple. I've also created a document here. So everything that we're talking in this episode or all the episodes, they are available as MD documents. Like you can use them as your notes. For example, here I've explained about infrastructure as code. Things are available here. Why Terraform? Whatever I explained, this is also available here. So you can use them as your quick reference before your interviews, or you can practice them, read through them once we complete these videos as well. So I'm trying to create this repository as best as possible. Now, so just go to this install.md where I've provided how to install for Windows, how to install for Linux, how to install for Mac. And apart from that, okay, I'll show this, but apart from this, like I told you, there is also a surprise, not surprise actually, for people who don't have their laptops. Some of you might be using your office laptops where there is a restriction that you cannot use install tools, or for some reason you cannot install Terraform on your laptop. You don't have resources or whatever is the reason. I will also talk about that so that it will be beneficial for those people. Now, the installation, like I told you, is pretty straightforward. You can just go to the downloads page. If you are on Mac OS, just click on this download page, right? Here you have how to install for Mac, how to install for Linux. So you can just copy these commands and install on your machine. For example, if you're on Mac, just select whatever it is. Let's say you're on AMD 64. Okay, so you can just run these commands and Terraform is installed on your machine. That's it. It's pretty straightforward. If you're on Linux, depending upon the distribution that you're on, if you're on Ubuntu, then again, just provide these things and these commands and your Terraform installation is done. So let me quickly show you so that you will also understand, right? So all that you need to do is take a terminal. Now, so I have a terminal, right? And in the terminal, what I'll do is I'll just copy whatever distribution that I'm on. Let's say I'm on Fedora, or let's say I'm on Ubuntu. Okay, you can just copy these commands and paste it on your terminal. That's it, nothing more than that. And Terraform is installed on my machine. Because I'm using a Mac, I already have used these commands and it is installed. If you're on Windows, only additional thing that you have to do, let's say you have a laptop that is Windows, what you need to do, click on the Windows button, select what kind of thing that you have. Mostly people have AMD 64, so you can just download, click on the download button, and what you need to do is you have to make sure that Terraform is installed in your path. Mostly the installers, once you click on the next button, like click on the download and click on next, and mostly Terraform is installed and configured to your path. But if it is not, then try to add Terraform to your path as well. And better use Git bash or any other terminals. Do not go with the CMD terminal that is there by default on your Windows machine, because you will face a lot of problems, right? Better use Git bash or PowerShell. Git bash is the most easiest ones, because most of your commands that you are using for Linux will also work on the Git bash. So install that. Now, let's say you don't have this option at all. You don't have a machine, and you just have your office machine, or in your laptop that you have, you don't have resources. The other thing that you can do is just go to this repository. You might have forked this repository, right? Click on the fork button and you will fork this repository, and you will see an option here called Codespaces. Okay, so you can use Codespaces, right? So just click on the plus button and create a Codespaces on the main branch. And the beauteous thing here is Codespaces is free for 60 hours a month, not beyond that. That means if you are using Codespaces, you will get Codespaces 30 days. If you use it for 30 days, you will get 2 hours each day. You can use it on your own basis. But what this Codespaces will give you, like I just clicked on the Codespace, and of course, because I have done the initial configuration, once you configure Codespace, it is easy for the next time. There are no things that you have to provide. Initially, it will just take some time to create a Codespace environment. But this is just like a virtual machine. It is actually a container that GitHub is providing you. So it is free for 60 hours. You can use it. It comes with 2 CPUs and 4 GB RAM for 60 hours free session. And here, if you just type, for example, let me increase the font. So by default, if you just search for Terraform -- version, Terraform will not be installed. If you search for AWS -- version, AWS will not be installed, right? What you can do is just go to the search button, right? Here, provide this arrow and say add dev container configuration files. This is very simple step. Just watch for a couple of minutes and your Terraform and AWS will be installed in your GitHub Codespace. What is GitHub Codespace? GitHub Codespace is a sandbox environment, or you can consider it as a container environment that GitHub is providing you free for 60 hours if you are using 2 GB RAM and 2 CPUs and 4 GB RAM. So here, just type whatever you require. So in my case, I am looking for Terraform. Oh, sorry. So modify your active configuration, click on that button and search for Terraform. Okay. So you will find something with this arrow, which means verified. So select this option. It installs Terraform, TFLint and TFGrunt on your machine, on your Codespace environment. Click on the OK button. Keep defaults, right? Now you will see a new file will be added, which is called devcontainer.json. And here you will see Terraform configuration. But till now, Terraform is not installed. If you again do Terraform -- version, Terraform is not installed. You have to do one additional step. But before doing that step, I want to install AWS as well. So again, provide that right arrow and search for add dev container configuration file. Click on modify your active configuration and search for AWS. So the first option that you see, click on the OK button, keep defaults. And now what I'm going to do, this is the final step. What you need to do here is just say right arrow, rebuild, and click on rebuild container. So it will ask you, do you want me to rebuild? Now what it is doing is it is trying to rebuild the container, the dev container that GitHub has provided you as part of code spaces, right? So what will happen with this is you will get a new container environment for you. Again, that is totally free for 60 hours, but this time your container will have both Terraform and AWS CLI installed for you. So this is a very good option for people who cannot install Terraform on their machine for any reason. You can use EC2 instances. You might be thinking that Abhishek, I can use EC2 instance as well, but the default EC2 instance that is free of cost. It comes with one RAM, right? It comes with one CPU and 1 GB RAM. And if you try to install Visual Studio Code or if you try to set up graphical user interface, then that instance will not support. So for that reasons, and because we are going to do a lot of practical learning in this Terraform Zero to Hero, you can use this code spaces approach. For any theoretical learning, you can watch my videos. And when it comes to practicals, you can use this. If you exceed 60 hours of time, create a new GitHub repository. And in that GitHub repository, again, configure your code space so that you get additional 60 hours of time, right? So it will take some time, this entire thing, for you to create a new container, dev container environment. It might take 5 minutes, it might take 10 minutes, but once it is done, you will get a dev container Visual Studio Code setup that is already there for you. Along with that, you have AWS and Terraform installed. I'm going to show you. So it will take like 5 to 10 minutes. So let me pause this video. Yeah. So now the environment is created. So you don't have to delete this file. Do not delete this file. You can keep it in your code spaces environment. And now if you search the terminal, right? So just close all of these things. This is the same Visual Studio environment that you can set up on your laptop. And when you practice Terraform, I'll highly recommend you to have Visual Studio Code installed, because that way you can practice things through an IDE. Real time people do in their organizations is that they use some IDEs. It can be Visual Studio Code, it can be IntelliJ, and VS Code is best suited for these kind of things. So let's use it. And here now, if you search for Terraform -- version, you will see Terraform is installed. AWS -- version, you will notice that AWS CLI is also installed. And because you have created this through the rebuilding of container, you can just close this code space. Now I've closed the code space. And if I go back and just refresh the page, right? And see here, this is the code space that I have on the current branch. Super Dummy Journey is the name that is given. Click on that and your code space will relaunch, and still you will have both the Terraform and AWS installed. So that way GitHub has given you a dedicated machine, and in that machine you have all the configuration that is required to practice throughout this course. So one final time, I'll just show you Terraform -- version. Perfect. It is already there. AWS -- version. It is already there. And here you can explore the files, right? Day 1 files are here, day 2 files are here. And from here, you can also execute your Terraform scripts, right? So everything is available, but only condition is it is available for 60 hours per month. If you want to use more than that, either you pay for GitHub code spaces or you create one more GitHub account. It is totally up to you. And if you have a perfect laptop where you don't have any concerns, then install Visual Studio Code on your laptop, install Terraform, install AWS CLI, I'll be talking about AWS configuration in a couple of minutes. But for now, I hope the Terraform installation is clear and VS Code setup is also clear. So VS Code setup, I'm not deep diving into it because you can just download VS Code by following some resources. Just come here and search for VS Code download. I hope most of you might already have it. If not, just go to this reference and download VS Code, right? Terraform also, just go to this page and download. If you don't have resources, use this example. Perfect. Now I hope I can go to the next topic. I have explained this in the last classes as well. So if you have an AWS account, if you don't have an AWS account, please watch my AWS DevOps Zero to Hero series where I've explained how to create an AWS account. And if you already have, what you need to configure Terraform for AWS is just go to your root user. Of course, you can use IAM user, and in your organization, it is recommended to use IAM users only because even a DevOps engineer or cloud engineer will not have the root access. So you will create an IAM user, but because this is the first class and I don't want to complicate it, what you can do is go to your root user or IAM user, go to the security credentials tab, and all that you need to do is fetch the information of your AWS access key. So this information, if you just scroll down, you will have something called access keys. So let's say, let me delete one of the access keys, right? So click on the actions, delete, just type this, deactivate, delete. So what you need to do, you need to click on create access key, say that I understand creating a root access key. So because I'm using the root user for the purpose of demo, so click on this and your access key and secret access key, right? Both of them are created. Now go back to your Visual Studio Code or terminal, whatever you are using. In this case, I'll continue on the code spaces itself. So you need to run this command called AWS configure. People who have watched my previous series, they are well aware of this concept. If you have not watched the previous series and if you don't have AWS account, please create AWS account first and then follow these steps. Now run AWS configure. It will first ask you for AWS access key ID. Copy this one, provide it here. Steps will not differ any terminal that you're using. Then copy this one, provide it here. This is your secret access key. No problem. I'll delete them right after the video. Default region. So you can just select US East 1. Default output format. You can say JSON. And that's it. Your AWS is now configured. To verify, just run commands like AWS S3 ls to just make sure that you are authenticated to AWS. Now I just said AWS S3 ls and you see it has listed all the S3 buckets. That means now my GitHub code spaces is able to authenticate to AWS. Understand it carefully. My GitHub code spaces is able to authenticate to AWS. Still now, we did not write any Terraform code. Till now, Terraform cannot authenticate with AWS. This is just step 1. And in step 2, we will write Terraform provider.tf file or we will write a Terraform file. And there I will show you how to configure AWS for Terraform, right? I'll just show you in a minute. But before that, I hope this step is clear. And to verify, what you can also do is go to your AWS UI, create a S3 bucket and run this command so that you can understand if this is perfectly configured or not. So let me quickly delete this one here itself, because you should never share any of this information, right? You should not be sharing your access keys or you should not be sharing your IAM user details with any of the team members as well, because it is very sensitive information. So now I've deleted it, right? So I'll reconfigure after this video. or I'll just stop the recording and reconfigure so that my security details are not compromised. Perfect. Now let's go ahead and see how to write this thing for Terraform, how to configure AWS for Terraform. That would be our last configuration step. So if you go to the GitHub repository, right? Here in the day one folder, you will find a file called projects. So this is a folder basically for every project that we are going to do in this. I'm going to upload folders. So this is the first project that we are doing. And what we are trying to do is we are trying to authenticate to AWS and create an EC2 instance. That is our first Terraform script that we are going to write. And for that purpose, I have already uploaded the file, the Terraform file. You can also view that in the code spaces view. So here you can click on day one folder. You can also open it in your Visual Studio Code and click on this main.tf button, right? So this is the Terraform configuration that is going to do the magic for us. Now you don't have to worry what is a provider. You don't have to worry what is resource, because we are going to cover that in detail. For now, I'll just give you a basic information. What we do in the main.tf file, firstly, we explain Terraform. Whenever we are writing code in Terraform, Terraform does not understand, are you writing this script for automating AWS? Are you writing this script for automating Azure or anything? So what we need to do is in our Visual Studio Code environment or terminal, we need to create a file. You don't have to create this inside a folder. You can create it anywhere. Just name the file as main.tf. The name can also be changed, but the reason I have named it as main.tf is because this is the main configuration file, right? It is always a good practice to name a file as main.tf, which holds the main configuration of your Terraform script. So I have called it as main.tf, but you can call it as Abhishek.tf as well. Inside the main.tf, the first thing that you write here is what is your provider configuration. And this syntax you just have to learn for one single time. So this is a comment that I've put. You don't have to put this comment. This is just to say that you can use any environment. You can just say US East 2, US West 1, anything, right? So you just need to learn this configuration one single time. This is also beautifully explained in the Terraform documentation. You can copy it from there as well. But from anywhere, you just say what is your provider. That is where Terraform has to automate the infrastructure. Followed by that, you will say if it is Azure, just replace this with Azure. If it is GCP, just replace this with GCP. So provider AWS, in the brackets, you have to mention what is the region. And what this step will do, this step will verify if Terraform has access to the AWS or not. When you run a particular command, I'm going to tell you what that particular command is. But right now, why do you write this block? You are explaining Terraform that AWS is the infrastructure where I want to automate, and region is US East 1. Now, after that, you have to provide resources that you want to create. If you want to create 10 resources, you will write 10 such blocks. Okay. If you want to create 15, you will write 15 such blocks. On a very basic level, I am explaining. So I have written this one. Now in the resource block, what I have written is what is the resource that I want to create. AWS underscore instance. Now you might be asking, but Abhishek, how do you know this? Very simple. You can just go to Google, search for Terraform AWS, right? So this is HashiCorp documentation where you can search for this syntaxes. For the very first time, nobody will know about this one. Nobody is expert. Even when I have learned Terraform, I copy. Even for now, sometimes I just go to the Terraform documentation and copy it from here. During the advanced demos, you will see I will go to this Terraform documentation. I'll copy some references from here, or sometimes I might be writing as well because I'm very used to it. But for now, what you need to do is go to the Terraform documentation. You want to create EC2 instance, right? In the filter, just search for EC2. Okay, so here you will get options what you want to create. Within EC2, I want to create a EC2 instance. So keep scrolling, you will find this particular thing. Click on that button and Terraform will give you some examples of how to create EC2 instances, right? So what is it saying? That these are some syntaxes, example usages. Create basic example with AMI lookup. No, I don't want that one, right? Here, spot instance example, network and credit specification. If you want to create some advanced EC2 instance configuration, if you want to create CPU options with examples, what you want to create, or you want to just create a very basic one, then this is the syntax. So I want to create a very basic one. So I will copy this configuration, and that's what I did even here. If you see here, I have a very basic instance configuration. So even if you don't know anything about Terraform, you can just copy it from the documentation. But as you keep writing, right, as you keep writing this Terraform files, you will learn about it. The only prerequisite here is you need to have the knowledge of cloud provider. If you don't have the knowledge of cloud provider, let's say you want to use Terraform with AWS, you need to have good knowledge on AWS. Without AWS knowledge, it is impossible for you to master Terraform, right? Because using Terraform, what you are doing, you are creating step by steps on AWS. So that's why I created the AWS zero to hero, and after that I'm doing Terraform zero to hero, right? So I just copied this one. I don't need host resource group, I don't need tenancy, so I just removed these things, and this is exactly what I've pasted here, right? So provider is default thing that you write in every Terraform script that you are doing. After that, any resource that you want, just go to AWS documentation, copy paste it. In future, I am going to tell you more and more tips and tricks as well. But for now, as part of day one, this is what we are going to do. Now, okay, I've provided AWS security credentials using AWS configure command. So my Terraform using this provider block, it will understand that it has to talk to AWS, and the credentials are also stored on this machine. So Terraform can use those credentials. After that, I have provided that, okay, this is the code. This is EC2 instance that I want to automate. What after that? After this, what you have to do? So after this, what you have to do is you have to run a bunch of Terraform commands, right? So this bunch of Terraform commands will help you to create infrastructure. Right now you just wrote the files, but the first Terraform command that you are going to do is called as Terraform init. Now what this Terraform init will do, it will initialize the configuration. This command will do the magic for you. This command will read the Terraform files, and here it will understand that, okay, I have to fetch the AWS credentials. So let me initialize that configuration for you. So as part of Terraform init, when you run this particular command, okay, what does it say? Terraform initialized in an empty directory. The directory has no Terraform configuration files. Why? Because I did not switch to the right directory. Within this repository, I have to go to day one folder, right? And inside the day one folder, what I need to do is I need to go to this folder called project. Okay, all of you, what you need to do is you have to clone this GitHub repository onto your local machines, and then you have to run this particular commands. Now I'm inside that folder, so I can run Terraform init. So now see what is it doing? Initializing provider plugins. Where did it get this provider plugins? So it read from your Terraform file that you want to use provider AWS. So it is getting some default plugins, and it said that perfect, your Terraform has been successfully initialized. Now I can talk to AWS. Now what I have to do next? So you have to tell Terraform to apply the configuration. So the command for that is Terraform apply. But before applying, there is one very good thing that Terraform provides, which is called as Terraform plan. What is plan? Plan is just like a dry run. It is a dry run where before creating the infrastructure or before applying the infrastructure, you can use this Terraform plan command and it will show you what exactly it is going to create. Understand it carefully. It is not creating the infrastructure, but it is just telling you when you run the plan command, it will show you that Abhishek, if you run the Terraform apply after this one, I am going to create all of these things. Are you okay with it? Right? So it is just like a dry run, or it is just like a verification that you are going to use within the Terraform to automate the infrastructure. Okay, something has failed here. Let me see what exactly it is. Okay, any guesses here why this is failing? So this is basically failing because I have deleted the security credentials, right? So what I'll do is I'll just pause the recording. So couple of minutes back when I was explaining you people, I've deleted the credentials. So what I'll do is I'll pause the recording. I'll create the credentials one more time and I'll show you after that how does this plan command work, right? So let me just pause recording. Okay, I have configured it. Now let me run the Terraform plan command. I hope it will work now. If not, we will try to fix it, right? So debugging will be part of this series where I'm not going to edit any of the things. Perfect. What is it saying now? See, this is the output of the plan command. And whenever you are running the plan command, please spend a couple of minutes and try to see what exactly your Terraform scripts are doing. Because sometimes you might do a very simple mistake and this plan command can act as a savior. Before creating, it is telling you what exactly are you going to perform, right? So what I usually do is whenever I run this plan command, I take couple of minutes and I read through everything. Here it is saying that Abhishek, Terraform will perform the following actions. It will create a resource called AWS instance, and this will be all of your details, right? Will be known after apply. That means right now it does not know what would be the details, right? Because the network interfaces and all of these things, it is not aware, but it can give you example, information such as instance type is going to be T2 micro. How did it say that? Because you have provided in the TF files. It can also give you information about AMI because you have provided the AMI details, right? Perfect. Now that is what it is saying, that one resource will be added, zero will be changed, and zero will be destroyed. Perfect. So now what I can do, because I'm comfortable with it, I can go ahead and run Terraform apply. Now, if I apply this configuration, you will see a instance is created if all of these details that I have provided is correct. It is asking, again, it is asking like one more step confirmation. Click on the yes button and Terraform will create EC2 instance if the AMI that you have provided is correct, if the instance type that you have provided is correct. Let's say if this AMI does not exist on the cloud provider, it will not create. That's what AWS has said. And I intentionally did it because I want to show you the error. So here AWS said that, okay, the AMI that you provided does not seems to exist. So what I can do is I can go to my AWS, right? Let me go to my AWS here and click on EC2. Perfect. Here I can pick up any AMI, sorry, not EMI. So here you can go to instances. If you don't know how to get AMIs, there are different ways. But if you are a beginner, click on the launch instance and pick up any AMI that you want. So here, let's say I want to use this one, Ubuntu. Okay. So here you'll get the AMI details. So you can just copy paste this one. Let's say you can select here and okay, how do I copy this one? What is the easy way? I can copy it from here. Okay, very bad. Perfect. So let me just take this one and update this one here. And if there will be any other issue, I'm going to fix it, right? So let me run this command one more time. Terraform apply. And again, it will ask you, are you sure about the configuration that you want to create? Click on the yes button. There are ways to avoid it. You can also ignore that yes as an input, but for now, let's restrict it. Now, again, you run into an error. What does it say? Creating EC2 instance, missing input, no subnets found for default VPC. Please specify a subnet. Status 400, right? So what is it saying? So it is saying that you have provided AMI, you have provided instance type, but what should be my subnet? So this is the reason why I told you that you need to have understanding of the cloud provider. Let's say you don't have understanding of AWS itself. Now you will not know what does the subnet mean here, what does the VPC mean here, how to create that configuration, right? So for that purpose, I did not complete this configuration to show you that you need more details. You need to understand the cloud provider configuration to create resources, right? So what I'm going to do here is I'm going to update these details and I will rerun. So what I'll do simply is go to the VPC configuration, right? So this is my default VPC. So just go to your AWS dashboard and click on the subnets button. Let's say you don't have any subnet, you can create a subnet, or if you already have a subnet, like in my case, this is my default VPC, right? And here I already have a subnet. So I can use this subnet as well. Copy paste this one, go back, and here just say subnet underscore ID is equals to this. Now, if you have seen, I'm getting this auto completion, right? So whenever I just type sub, you will see some suggestions here. Now, why are you seeing that suggestions? Is because I am using something called as HCL plugin. So just click on your extensions button and here you can install this particular plugin called HashiCorp Terraform, right? If you just search for HashiCorp, you are going to get this one, and just search for HCL, right? So HashiCorp HCL syntax. Also install this one. Perfect. So install HashiCorp and install this HashiCorp HCL. I will tell you what is the advantage of using this HashiCorp HCL plugin. It will help you with linting. It will help you with other things as we progress with this series. But for now, just install those two plugins. So I have provided the subnet details as well. And along with this, you can also provide key value pair, right? So let's say in your account, you already have a key value pair. What you will do is just go to your account, search for key pair, EC2, and here you will have key pairs. If you don't have key pair, create a key pair, because key pairs are useful to log into the instance. So I already have a key pair called AWS login. So let me just copy this one and enter. Now I hope this is complete and I hope it works. So let me try this one more time. Terraform apply. See, this is part of debugging. Of course, this is a very simple one and I've done most of the things intentionally because you people are just learning Terraform. So I thought I will put the wrong AMI. I'll put, I'll ignore the subnet details so that you will understand what is the error and how to fix it. But two things you might have understood by now is, one is when you are using Terraform, you should have knowledge on that particular cloud provider. And the second thing is you need to have some plugins and good idea of how to use the Terraform documentation. And that's where I'm going to help you throughout this series. I will make sure that you will master the Terraform documentation, how to use Terraform documentation and write the Terraform scripts. Perfect. So if you see here, it says apply complete. Let's go to the AWS dashboard, click on EC2, and let's see if the EC2 instance is created. One instance is running. Is the name of the instance example? So what did it say? This is the instance ID. Perfect. Let's go and see here. Of course, the name is not created because I did not give the tag, but the instance ID should be this one. It should end with 3D7. 3D7. Perfect. So the instance is created, and clap for yourself. You have created your first Terraform script to create AWS EC2 instance. And I will submit these things to the GitHub repository, or let's give it as an assignment. So I already have these things here, right? If you go to the Terraform 0 to Hero, the entire project is already uploaded, but I have ignored the subnet and I have ignored the key pair because you will run into some errors, and let's see how many of you will be able to fix. That way you will run your first Terraform script, right? So till now, what did we understand? We have understood why Terraform, what is the importance of it, how to write your first Terraform. We have all the things documented here. So take it as a recap for today's video and watch it. Finally, one thing that is left for me to explain is what is the Terraform state file. So like I told you in this video, it is not that important, but if you just do ls, you will see that there is this file created called terraform.tf state. And if you just do cat on this file, you will see that Terraform has updated this file with lot of details. Now, what exactly these details are? So Terraform makes use of this state file, right? It uses this state file to record whatever it is creating. So next time when you write a new Terraform script, or you will add more script to this, like instead of along with this EC2 instance, let's say here you will write resource, right? Let's say S3 bucket, or you want to create EBS that is supporting this EC2 instance or whatever it is. So how does Terraform know that previously you have created EC2 instance? So to record that information, Terraform makes use of this state file. In the future classes, we will learn about this state file, how to secure sensitive information in the state file, how to use remote state file, local state file, how to run Terraform in the CI/CD. All of these things we will learn, where we will focus more on the state file. But for now, don't get confused. Why is this file created? It is used by Terraform to record whatever infrastructure it is creating, right? And finally, once you're done with this demo, just run this command called terraform destroy. And what Terraform will do is Terraform will look at this state file and understand, okay, I have created an EC2 instance. Abhishek is asking to destroy. So let me destroy that EC2 instance so that you will not be billed, right? So always when you're performing the demos, final thing that you have to do is to run the terraform destroy command and just say yes. And you will notice that the EC2 instance that you have created will be destroyed as well. So this is the complete life cycle of Terraform. Terraform init, Terraform plan, Terraform apply, and Terraform destroy. What did we learn? The life cycle of Terraform is 4 phases. Init, which will initialize the Terraform configuration. It will get the sensitive information. Sorry, it will get the password. It will authenticate with AWS. It will do the provider configuration. Then Terraform plan, which will show you what exactly is being created. Terraform apply, which applies the configuration, and destroy, which destroyed. If you go back, refresh, you will see the EC2 instance is deleted. Perfect. So this is the Terraform demo for you, and this is day 1, and day 2, 3, 4, 5, 6, 7 are going to be super exciting. And I hope you like this Codespaces trick as well. And that is the reason why I performed today's entire video on the Codespaces, because I want you people to be acquainted with it. When you move to organizations, you might see people using something like this, and you should not be scared. You should not be thinking, okay, what exactly these people are using? Why are they not using their laptop? What is Codespaces? Why are they doing everything here? So it is something like a trick or something, or something very cool that you can use. You don't have to create dependency on your laptop. Tomorrow you go to your friend's house, you go to your colleague's house, you can just log into your GitHub from their laptop and you can access your Codespaces. So it will remove the dependency of your laptop. Perfect. So use this trick. Even if you have your laptop, just try to do it on Codespaces. It's super cool. Thank you so much for watching today's video. I hope it is informative. Take care, everyone. See you. Hello, everyone. My name is Abhishek and welcome back to my channel. Today is day 2 of Terraform Zero to Hero series. And before I explain you what we will learn as part of day 2, let's quickly recap what we have learned on day 1. So on day 1, we started with understanding the concept of infrastructure as code, how and why Terraform is the key player in the space of infrastructure as code. After that, we learned how to install Terraform on Linux, Mac OS, and Windows. Apart from that, I've also explained you how to set up Terraform in GitHub Codespaces. GitHub Codespaces is very powerful because you get it for 60 hours free with 2 CPU and 4 GB RAM. So if you don't have a proper workstation or you are using your office laptop and you cannot install Terraform in it, so you should explore the option of GitHub Codespaces. And after that, I have explained how to set up Terraform for AWS, because most of this series we will try to automate infrastructure on AWS. And in the last class, we have created EC2 instance. So I've explained you how to configure Terraform for AWS, how to give your AWS security credentials, all of these things. Then we moved ahead and understood the concept of Terraform lifecycle. What is Terraform plan? What is Terraform apply, init, destroy? All of these things we try to understand with example. And finally, I just touched the concept of Terraform state, because on day 4, we will deep dive into the concept of Terraform Statefile. What are the advantages of Statefile? What are the disadvantages of the Statefile? What is remote state? I mean, remote backend. All of these things will be covered as part of day 4. So you need to understand what is Statefile doing. So that's why I just explained the basic concepts of Statefile in day 1. Going back to the actual discussion for today, that is day 2. So what exactly are we going to learn as part of day 2? In today's video, we will learn what is provider in detail, what are the different types of providers, how to configure providers. We will talk about providers for multiple regions, providers for multiple cloud, that is the hybrid cloud. We will also learn that. And then I will explain you how to write resources in Terraform. What exactly is resources? Then we will understand about variables in Terraform, input variables, output variables, TF-vars. We will understand about these things. After that, we will learn about conditional expressions and functions in Terraform. Finally, I'll explain you about debugging and formatting in Terraform. So these are some of the things that we will cover today, and it is going to be power packed. If you look at day 2 folder, I have written the complete notes. Let's say at some point of the video, you are not able to follow, then you can use this notes as your reference. For example, whatever I'll be talking about providers is already available here. And whatever I'll be talking about, let's say resources or variables, TF-vars, all of these things with examples is available. So please try to watch the video till the end. And after that, you can recap by following the documentation. Just by following documentation or just by following the video, you will learn things. But to get 100% knowledge on what I'm explaining on day 2, follow the video till the end and quickly recap what we have provided in the day 2 folder. Providers. So there are some really cool scenario based interview questions related to providers, which we'll also try to cover in today's video. But before that, when we created EC2 instance on the AWS platform the other day, what is the first thing that we wrote in the main.tf file? So the very first thing that we have written in the main.tf file is the provider block. We said provider, inside the double quotes, we mentioned AWS, and within the braces, we provided the configuration of this. We said region, whatever the region that you would like to. And apart from that, if you want, you can also mention what is the AWS secret key, what is the access key ID. All of those things can also be mentioned in the provider block. But what if I don't mention this provider block itself? And if I just proceed with creating the EC2 instance logic where I can just say resource followed by AWS underscore instance followed by the name of the resource, and inside the block I'll just mention what is my AMI ID and I'll mention what is the instance type, for example. And I will just run Terraform init, and let's say this got succeeded, and I will run Terraform apply. So what will happen is, how will Terraform apply, or how will Terraform understand where it has to create this resource and how to authenticate to that particular cloud provider? All of that information is available through this provider block. So provider is nothing but provider is a plugin that helps that helps Terraform to understand where it has to create the infrastructure, right? So it acts as a medium for Terraform to understand where these resources or where the entire project has to be created. Without provider, it is not possible. Now, what if, instead of AWS, what if you want to create infrastructure on Azure, GCP, Alibaba Cloud? So where will I understand how to configure this provider, right? So if it is AWS, I told in the last video that this is how you have to do. Don't worry. You can just go to the Terraform providers page, and there are hundreds of providers. As of today, Terraform provides so many providers, but there are categorized into three types: official providers, partner providers, and community providers. Official providers, like if you uncheck these other two things, right, bunch of things will go away. Official providers are the ones that HashiCorp actively maintains. So HashiCorp is the creator of Terraform, and they actively maintain these providers like AWS, Azure, Google Cloud Platform, and Kubernetes. So you can trust them. You can rely on these providers because there is someone who is backing up these providers. Whereas the other things are partner providers and community providers. So partner providers are these ones where, let's say, Alibaba Cloud, HashiCorp did not create the provider for them. What Alibaba Cloud said is, okay, we will write the resources. We will tell Terraform how to authenticate with us and how to create infrastructure on us. And we will actively maintain this particular provider. That is Alibaba Cloud, Oracle, and some others. Now, apart from that, there is something called as community providers, where community providers are something where you and I can also create the entire provider configuration, and open source will maintain these providers, right? There is no official backing up by HashiCorp or official backing up by partner providers or any partners of HashiCorp. So you don't have to worry this that much. But only thing is, let's say in your organization, you are trying to automate something very different, like apart from AWS, Azure, or Google Cloud Platform. Let's say you are using a different cloud, or you are trying to create infrastructure somewhere else. You have to make sure that at least if it is community provider, there is some active contributions that are made to it, right? If there are no active contributions made to it, then it is not that much suggested to use that Terraform provider. Apart from that, if you're using partner or official providers, there is no problem at all. Now, going back to the topic, if you want to look at the configuration, or if you want to read about particular provider, just click on these buttons and you will learn everything about that particular provider, right? When are the last updates, how to use that particular providers, how to write configuration for them, everything is available. But in the interviews, usually interviewers focus on a couple of things. That is, in yesterday's video, we learned how to create in a particular region. But what if you want to use multi-region, right? You want to use Terraform to set up infrastructure in multiple regions. Or how do you set up Terraform to create infrastructure on multiple cloud? That is, if your organization is on hybrid cloud, then how do you use Terraform? These are two popular things. One is the hybrid cloud architecture of Terraform, and the other is multi-region setup of Terraform. So how do you do that? Because in yesterday's video, we just wrote provider for one particular region. So don't worry. What you do is you just mention. So if you go back to the document here, I have provided both the examples. This is for multi-provider and this is for multi-region. Let's start with multi-region. So let's say you're using AWS and you want to automate infrastructure on US East 1 as well as US West 2. So what you will do is instead of one provider block, you will write two provider blocks. So in the first provider block, you will say that provider is AWS, and watch this carefully. You will use a keyword called alias. And for US West 2, again, you will write the provider block and you will create a different alias. And when you are trying to create EC2 instance, exactly what we have done yesterday, we have just written these two things, right? We said resource, AWS instance, example, and we provided what is the AMI and what is the instance type. Apart from that, when you want to create resources in multiple regions, you can create a alias for your provider, and within that particular resource block, you can say provider is equals to AWS dot the name of the alias. So here I said AWS dot, what is the value of the alias? US East 1. So by looking at this, Terraform will understand that, okay, I have to create this resource on the provider called AWS.US East 1. That is this particular thing, AWS.US East 1. Sorry, this one, AWS.US East 1. It will go to the alias and there it will identify, okay, my region is US East 1. So this alias can be anything. It does not have to be similar to the region name. You can just call it as ABC, XYZ, whatever you would like to. Got it? So this is how you set up Terraform for multiple region. Now, how do you set up Terraform for multiple cloud? So this is about multi-region. But what if your organization is in hybrid cloud? In such cases, similar to the above, but here you will configure providers with different names. So AWS has the provider name as AWS, whereas Azure has the provider name as Azure RM. That's why I showed you, you need to go to the official documentation. Because without going to the documentation, you will not understand what should you provide the name here, right? So let's say I will go to Azure. Here I will understand that, okay, the name of the Azure provider is Azure RM. So that's why if you watch carefully here in the first block, I've wrote provider AWS. In the second block, I've written provider Azure RM. And inside that, similar to AWS configuration, for Azure, you will have a different configuration, right? For AWS, you just mention what is the region. And if you're using AWS CLI to configure it, which is something that we did yesterday. So that's why we did not provide any AWS credentials. But if you don't use AWS CLI to authenticate, then here you have to mention what is your access key ID, what is your secret access key ID. That's what we are doing in Azure as well. What is the subscription ID? What is client ID, client secret, and tenant ID? Because Azure has a different mechanism, right? In Azure, you have service principal, whereas in AWS, you typically go with the IAM thing. And after that, it is very, very common. Once you provide both of these things, it is the resources. Like for AWS, the resource name would be AWS instance to create a virtual machine. For Azure, the resource would be Azure RM. Now you might ask me, but Abhishek, if I have to write this block, if I have to create resources on Azure, how will I understand? How do you know? Like maybe if I am writing, how do I know? So it is very simple. Just go to the Terraform Azure, right? Docs overview, HashiCorp Azure RM. Now nobody, whoever the DevOps engineer is, whoever the cloud engineer is, nobody will remember all of these things, right? Nobody can remember what is the name for AWS for virtual machine, what is the resource name for virtual machine in Azure, and there are hundreds of resources in AWS. There are hundreds of resources in Azure. So even if you are working in an organization, you will not have that complete knowledge. You just have to go to the official documentation, and in the official documentation, you have to search for it. So what did I do? I just searched for virtual machine and I got this. What is it called? Azure RM underscore virtual machine. So that's why I wrote resource Azure RM underscore virtual machine. And here you will have bunch of examples as well. So using these examples, like for example, this is how you write this one, right? For writing virtual machine. So this is the block. So Azure provider is already giving you some examples. What you need to do is you need to take these examples, you have to modify it accordingly. That is what we will learn in this series, don't worry. But at this point of time, when you are trying to understand what is resources, it is my responsibility to tell you that anyone, whether they are working professionals, they have 10 years experience, 15 years experience, still we have to reference the documentation, because you cannot remember all of these things. And if you try to remember, then you are wasting your time. In your interviews, when someone asks you, you can just tell them that I don't remember the syntax 100%, but I can give you a rough overview. And that is what is expected in your interviews as well. Nobody will expect you to write this entire thing as is, because this is not a program, right? This is taken from the documentation. This is according to the Azure RM documentation. Got it? So you should be able to understand, if you want to create a virtual machine, what you need to write, you need to know the skeleton. Okay, we will do that when we go to a project. I will explain you step by step how to do that, don't worry. But at this point of time, just understand that resource you will get from the official documentation. You can take help of official documentation. And what is this resource indicating? In AWS, if you want to create EC2 instance, this resource indicates that for EC2 instance, you are writing this block of code. In Azure, if you want to create virtual machine, so for Azure virtual machine, you are writing this block of code. One more thing you have to understand is, if you don't know how to create resources manually on AWS, or if you don't know how to create resources manually on Azure, then learning Terraform will not be helpful at all. I'm again telling you, if you are directly trying to learn Terraform without understanding the concept of AWS cloud provider, without understanding how to create, let's say your task is to create VPC using Terraform. And if you don't know how to create VPC from the UI, then do not learn Terraform. Firstly, go and learn how to create resources on AWS, because that is the same thing that we'll try to put in implementation in Terraform. Okay, perfect. So you understood what is providers, you understood how to configure multiple provider, you understood how to set up multi-region architecture in Terraform. Then let's move to another concept, which is called as variables. Now, variables is quite common. Any programming language that you are trying to learn, or any scripting that you are trying to learn, you will use variables. What is the advantage of using variables? Variables is used to parameterize. Okay, so they can be used as params to pass values to your projects. Same in Terraform. What you will try to do is, let's say you write a standard Terraform project, and this Terraform project is used by one particular team. Later, other team comes up with the same request. So if you are hard coding the values in the Terraform, if you go back to yesterday's learning, so what did I do here? Because that was our first project. In the main.tf, I have hard coded the AMI value. I have hard coded the instance type. But this is not a good practice. Why? Because if some other team, as a DevOps person, you will support multiple teams. So let's say some other team comes to you and tells that, Abhishek, I want a Terraform project for creating EC2 instance. You already have one. Why you want to write this again and again? If you are hard coding the AMI value, and if you are hard coding the instance type, that is what you will do. You will rewrite this entire project for another team. So to solve this problem, what you will do is, instead of providing the AMI value as a string like this, you can replace this with a variable. Instead of writing instance type value in a string like this, you can replace that using a variable. And in Terraform, there are typically two types of variables. One is called as input variable, and the other is called as output variable. What is input variable and what is output variable? Let's say you want to pass some information to Terraform, then it is called as input variable. Or if you want Terraform to print a particular value in the output. Yesterday, when we created EC2 instance, when we performed Terraform apply, we saw that Terraform is giving back a bunch of information, right? Or Terraform just said that one resource is created. But let's say after the EC2 instance creation, you don't want to go to the AWS UI and you don't want to check the public IP. Let's say your EC2 instance is available publicly. So what you can do here is in the output variable, I'll show you the format as well. You can tell Terraform that print the public IP. And what will happen is every time this Terraform project is run, once the Terraform creates resources on AWS, as an output, it will give you public IP back. You can see the public IP on your console. And input variables, we all know what input variables are. The same example that I talked about. If you want to parameterize AMI in the above example, or if you want to parameterize instance type in the above example, then you need to pass those things as an input variables. I'll show you some examples. So here the examples are also available. So instead of creating the resource, here I have created an example resource, and what did I provide the name of the resource as? var.example_var. And where did I create this example var? I have created using this syntax. Now let me explain how to do it for an EC2 instance, because you all know at this point of time how to create an EC2 instance using Terraform. So let me explain that here itself. Now I will create something called as main.tf. Okay. Inside the main.tf, as usually, I'll write the provider configuration, or I can write the provider configuration in the provider.tf as well. Let's say I've written that in the main.tf. I wrote a bunch of things inside the provider configuration. Then what I'll do is I will say resource AWS_instance. Just provide a name of the resource. Let's call it as example. And inside that, instead of hard coding the AMI, okay, what I'll do, AMI is equals to var.AMI_value. And instance type, what I'll say is var.instance_type. But where will I get these variables from? So what you need to do is before the resource, okay, in between the provider and resource configuration, what you will try to do here is you will write all the variables that you want to use. So here you can see the variable implementation. So I've created two files. One is variables.md, which has information of whatever I've explained till now. So all of these things you can summarize. This particular file called variable.tf, here I've written the same script that we used yesterday. Yesterday we used main.tf and we just created the resource directly, right? We created this particular resource. But here if you see today, what I did is I replaced this thing with var.AMI_ID. What did we do in yesterday's class? Let me take that in a different tab. Okay. So here, if you see, this is the main.tf that we used yesterday, and these fields are hard coded. This is the AMI and this is T2 micro. Whereas in today's video, here I said AMI is equals to var.AMI_ID. Instance type is equals to var.instance type. And where am I getting these fields from? So before you write the resource block, you need to create these variables. Okay. And this is the syntax for creating a variable. Let's see what would be the fields that would be going inside it. First, you start with the keyword called variable. And after that, you should be providing what is the name of the variable that you want to use. So here, the name of the variable I want to use is instance ID. So instance type is equals to var.instance type. So here I'll say variable instance type, and inside it, description is not mandatory. You can avoid description, but just for the readability, whoever is reading your project, they need to understand. This is very, very important in any programming language. When you are creating a variable, if it is a statically typed programming language, okay, I'll not go into the details of it, but you will mention what is the type of a variable, right? So here the type of the variable is a string. It can be Boolean or it can be any other kind as well. So here the type of the variable is string, and what is the default value? T2 micro. Now, whenever you use this particular variable using var dot name of the variable, so var dot instance type. See, that is what is referenced here. What would be replaced when you use var.instance type? This particular var.instance type would be replaced with the default value, that is T2 micro. If you don't have a default value, I'll explain you what you need to do. But when you provide default, what will happen is the var.instance type would be replaced with this particular thing. So what will happen with this is you are not hard coding these fields. You are using that in a separate variable section, and you can update this variable section from the Terraform apply command as well. That means you can pass the values to these variables from the Terraform apply command, or you can put the values of this in a different Terraform file as well, which is called tfvars. I'll talk about it in a couple of minutes. But for now, I hope you understood what exactly we are trying to do using variables. We are trying to parameterize our Terraform project so that it is not just used by one particular team that you are supporting as a DevOps member. You can redistribute or you can reuse this particular Terraform project with a different team. Got it? So these are the input variables. Okay, whatever you are trying to pass here, these two information you are trying to pass to the Terraform project. So these are called input variables. Whereas you can also use output variables, but the syntax will be slightly different. The syntax for the output variables will start with output keyword, which you are asking Terraform to give back once the Terraform apply command is successful. Let's say I want to get the AWS instance public IP. So I'll say output public IP, and here I'll mention what is the value that I'm looking for. So I am looking for the public IP of AWS instance dot example instance. This is the one, right? Resource name dot, resource keyword dot, or you can just say that AWS instance, which is the resource dot resource name. I think this is perfect. You can call it as resource dot resource name. Let's say you want for a different EC2 instance, you will say AWS instance dot example instance 2, or whatever is the name of that particular resource, and followed by the public IP, because you are looking for the public IP, right? So when you use output as a keyword, you are telling Terraform to give me that particular information. When you are providing or when you are prefixing with variable as a keyword, you are telling Terraform that take this as value, right? So this is nothing but input variables and output variables. The other important thing is, whenever you write Terraform projects in your organization, right now we are writing very simple Terraform projects, but there will be a structure for your Terraform project, because you cannot write everything in one simple main.tf. So what you will do is you will split this. The provider configuration from the main.tf can be written in provider.tf file. The input variables that you are trying to pass, whatever we saw till now, they can be provided in the input.tf. The output variables can be provided in the output.tf. This is a standard practice. You can change the names of these files, but if you use this standard way, anybody who is reading your project, they will understand. And then you can have a file called main.tf, right? So this is a structure that is commonly followed. And apart from this, there is something called Terraform.tfvars. Now this is very, very important to understand, and I'll make it very, very simple for you. So here we are using variables, right? And if you are passing default value to a variable, that is fine. But how to parameterize completely? That means when you are executing this particular Terraform project, I want to take the values of this variable dynamically. So this instance type for one project that the DevOps team is supporting is T2 micro. But tomorrow someone comes and execute this, they want the instance type to be T2 medium. Someone wants T1 micro. So how to completely parameterize it, or how to pass the value to this variable? In Terraform, there is a concept called tfvars. Okay, so tfvars, you can let me go back. Yeah, so this is the tfvars file where I've written. Using tfvars, what you will try to do is you will try to put the values to these variables. That means you wrote this entire files, you wrote the input.tf, you wrote the output.tf. Along with that, you can create a file called terraform.tfvars, and inside the terraform tfvars file, you will write that AWS underscore instance is equals to T2 medium, or instance type is equals to T2.medium. Don't worry, we will do the practicals for each and everything. Here, I'm just trying to explain you the concepts. So this is theoretical understanding. When we move to practical, you will understand in detail how to write each and every file. So in terraform.tfvars file, you will write the actual values of these variables. Okay. So what is the advantage of that? Tomorrow, any team that tries to execute this entire project, they can just change the tfvars file. Or let's say you have the Terraform project for dev environment, staging environment, and production environment. Okay. So you want to use the same Terraform project for different environments. Okay. And for one environment, your Terraform script for the EC2 instance, the Terraform instance type for the dev environment is T2 micro. Whereas for production environment, the value is T2 medium, or it can be different from project to project. So what you will do is inside the input.tf, you will create that variable, but inside the terraform.tfvars, you will actually pass the value to it. It is just like a key value pair file where inside that file, you will write values of each and every variable that you are creating in input.tf. Let's say you want to write the value of instance type. So you will just say instance underscore type is equals to T2 micro. Then key value pair, let's say key name is equals to something. Let's say you want to provide some information about security groups, subnet IDs. All of these things you can provide in this tfvars file. And when you run Terraform apply, by default, Terraform will look for this file called terraform.tfvars, and it will replace or it will update the values in the input.tf, right? Whatever you provide in the input.tf. Here, this value called AMI ID would be updated from the tfvars. I mean, this particular thing, the default will be updated with whatever you provide in the tfvars. If there is no default value, even then the tfvars value will be taken as the AMI ID. So advantage that you are getting is, if some other team is trying to use the same project, they can simply update the tfvars file. Okay. When we move towards the practical, you can see in live how we are doing it. There is also one example that I'm giving for today, but in another class, we will try to do the complete demo. And during that demo, we will write each and every file that we are talking about. We will write input.tf, we will write output.tf, main.tf, tfvars, everything will be written. Don't worry about it. Okay. So tfvars file, by default, the name is terraform.tfvars. If you want to change it, let's say you want to call it as dev.tfvars. In such case, what you will do is you need to pass that information to the Terraform apply command. Okay. You will say what is the name of the tfvars. If you are using terraform.tfvars, you don't need to pass that to the Terraform apply. But if you are changing the name, you need to pass that to the Terraform apply. Got it? So this is about input variables, output variables, and tfvars file. Apart from that, what is left for us to learn today in today's class is what is conditional expressions in Terraform. This is again a very good concept. So conditional expressions are nothing but, in some cases, you want to execute. Let's say there is a resource block. Okay. And this particular resource block called, we will use the same example, AWS underscore instance. Okay. And in that particular resource, you want to execute some values. Okay. Let's say there are 10 values, or let's say there are 12 values, and you want to execute 12 of these values on dev environment. Whereas if it is a prod AWS cluster or prod AWS environment, you want to modify value of a couple of fields, or you don't want couple of fields to be executed. I'll take a very simple example. Let's say you have a S3 bucket. If you are creating S3 bucket on dev cluster, that is on the dev AWS environment, let's say you want to enable public bucket access, just for easy thing, right? If you enable public access, you can simply host a static website. Whereas if it is a prod cluster, you don't want to enable the public access to the S3 bucket. So what are you trying to do here? You are trying to perform conditional actions. If you are aware of any programming language, such situations usually are handled by if conditions, right? In programming language, you usually have if conditions, else conditions, whereas in Terraform, you have something called as conditional operators. So the syntax for the conditional operator is, firstly, you will provide the condition. If the condition is true, you will execute the true value, that is the first value. If the condition fails, then you will execute the second value. I'll show you. So let's take example here. This is a very simple example where what you are trying to do is you are trying to create a resource called security group. In AWS, you want to create a security group. You have provided the name of the security group. You have provided the description of the security group. And in the security group, you are saying allow 22, which is allow SSH, but only, only allow for only allow for a particular CIDR block. That means allow SSH to this particular instance where the security group is assigned, where if the environment is production, then assign this particular CIDR block. Okay. If the environment is not production, then assign this particular CIDR block. That is, if the environment is production, if it is a production AWS cluster, production AWS environment, you will allow SSH access to one particular subnet range. If it is dev environment, you will allow SSH access to the instance to a particular subnet block. So here I have used variables. What did I say? At var.production subnet CIDR. What is var.production subnet CIDR? The default value is 10.0.1.0-24. Whereas for the development, the value is 10.0.2.0-24. So if this condition is matching, then SSH access is allowed for this particular subnet block. If the condition is failing, SSH access is allowed for this particular subnet range. Got it? So this is how you can use some conditional blocks, right, in Terraform. This is very, very handy. I just took example of security group. You can take any other examples like I provided, let's say S3 bucket access, right? Do you want to keep it public for dev environment? If you want to keep it public, then you can use this CIDR, you can use this conditional operator and say that if your S3 bucket is on the production environment, disable public access. If it is on the dev environment, enable public access. You can use the similar kind of condition, right? var.environment equals to production, then true and false. Got it? So right now you might not be knowing how to create resource for S3 bucket. Of course, you will go to the documentation, and what you will do is you will see all of these parameters, and for one of the parameter where they have public access enabled or disabled, you will use this particular condition. So this condition is also called conditional operator. In some programming language, we use this as if and else conditions. You can call it anything that you would like in Terraform, but the concept that you need to understand is they are helping you to execute resources using conditions. Got it? So this is very, very important in Terraform. When you try to use Terraform for multiple environments, when you try to create Terraform complicated infrastructure, you will use the conditional operator. Then if we go back, we have something called as built-in functions. So in built-in functions, of course, you cannot learn these built-in functions without actually using them, because again, they are like keywords. And if at all there is a use case, you will use particular thing. If you don't have use case, then you will forget about it. So this thing comes with practice, but you need to understand that just like any other programming language, there are some built-in functions for Terraform as well. For example, you have a built-in function called length. If you append length before a particular list, then it will give you the output, which is the length of that particular list. Similarly, you have a map where if you provide a key and a value, this particular map keyword or this particular map built-in function, it will convert the output into the map format, into the key value format, right? So I've given bunch of built-in functions. This is just for your reference. The reason why I've provided you this built-in functions in this class is when you are learning about variables, when you are learning about the operators, I thought it is important for you to understand that there is something called built-in functions, and you can just go over this particular document. And if at all we will be using this when we create infrastructure, when we do project in Terraform, then I'll let you know that we are using a built-in function. Like I told you in day 2, this is how you have to reference it. So this is today's video. There is also a project which I have already explained in my AWS Zero to Hero class. We have collaborated with CloudChamp and we have created it. So for people who already have watched that, you don't have to again go to it and you don't have to perform it. But if you are a new learner of Terraform and you did not watch that particular video, you can just go to this particular project and you can read through the information. This is again a very simple one. I did not use any input.tf. I did not use any output.tf. I just created all of the things inside the main.tf itself. So you can quickly walk through this entire main.tf and understand how this is written. But don't worry, like I told you, the main.tf, input.tf, output.tf, and the entire structure of the Terraform with the demo will be performed in this Terraform Zero to Hero series, where you will understand end to end. So that's all I have for today's video. I hope you found this informative. Before going towards the next class, please try to read everything that I tried to put here. I've taken so much time in writing all of this information. So I hope you'll find it useful and share it with people who are trying to learn Terraform. Thank you so much. See you all in the next video. Take care. Bye-bye. Hello everyone. My name is Abhishek and welcome back to my channel. Today is day 3 of Terraform Zero to Hero series. And in this video, we will deep dive into one of the most important concepts of Terraform, that is modules. Please watch this video till the end because we will not only cover the theory part, that is scenarios, advantages of using modules, but we will also do an end-to-end demonstration. That means we will write a regular Terraform project and then we will convert that into a Terraform module. So it's going to be interesting. So please watch it till the end. Before we do that, let's quickly recap what we have learned as part of day 2. So as part of day 2, we understood what is a provider in Terraform in detail. We learned how to use multiple providers in a single Terraform project. That means using one Terraform project, how can you automate multiple cloud infrastructures or multiple providers? Then we have learned about the concept of multiple regions, where we can use Terraform to automate infrastructure in 2 different regions, or you can set up a multi-region architecture using Terraform. Then we have learned about the concept of variables. We understood what are variables, what are output variables, how to use TF-vars, how to pass the values to the variables. So these are all the things. And finally, we learned about conditional expressions in Terraform. So please again watch it till the end because we will use all of these things in today's video to create the initial project, and using the concept of modules, we will convert this entire project into Terraform module. Okay, let's start with understanding what exactly is a module in Terraform. Let's take a real life example so that you understand this in a better way. For example, you are working in an organization and this particular organization has some millions of lines of source code. Let's say this source code is written in Java and the name of the company, for instance, let's call it as Amazon.com. We all know that these days, every company is using the microservice architecture. But for an instance, let's assume that this company is using a monolith application or monolithic architecture. What does that mean? All 1 million of lines of code is written as a one single application or one single project. Now, you might be thinking that, okay, everything is written as part of one single application. What is the problem? Now, the problem would be, let's say there is a bug on this particular application, and there is a new person who has just joined the team, and you have assigned this new person with this particular bug. So this person would take ages to understand where exactly the bug is, or this person would take a lot of time to firstly read the entire 1 million lines of code, because there is a bug and technically it is not easy to understand where exactly the bug is. So this person would end up spending a lot of days to just understand where the bug is. And second thing is, there would be lack of ownership, right? So let's say again there is a bug, and you want to assign this particular bug to any particular developer and tell them that, okay, try to fix this bug, because this is created due to the code or due to the changes that you have implemented. That would be not possible, because there can be hundreds of developers writing this millions of lines of code, and you cannot say exactly that who owns which part of the code. Like, you cannot say that, okay, out of 1 million lines of code, first 10,000 lines is owned by X developer, 10,000 lines is owned by Y developer, or in this 1 million lines of code, there can be some 1,000 functions, right? It will be not easy to say that first developer owns 10 functions, other developer owns the other 10 functions. So there will be a lack of ownership. And third thing would be, maintenance would be very, very difficult thing. What does that mean? Let's say you want to keep upgrading this particular application, right? You want to make sure that this particular application does not have any security vulnerabilities. So the problem is, again, because this is one single application, has millions of lines of code, it is practically, it creates a lot of challenges to maintain the application. So to address all of these things, and beyond this, there is another simple thing. That is, let's say you figured out the bug as well, and you try to fix this thing. Now, to test this particular piece of code, right? Which part of the application would you test? Because it is one single application, you will test the entire application and you will deploy the entire application. So testing would also be very, very difficult. So to address all of these things, what developers have done, or what the software industry has done, is they have transitioned from the monolithic architecture to the microservice architecture. Now you might be wondering, but Abhishek, why are you telling us all of these things in today's video? So it has a great relation. The same thing happens with Terraform as well. Let's try to understand how. So even with Terraform, there will be one particular provider that you try to automate, right? So usually these days in companies, mostly there will be one single provider, but at cases, if you are working in a hybrid cloud architecture, you might work on multiple providers as well. But for the purpose of video, let's say that in your organization, you are using AWS and you are using Terraform to automate the AWS. Okay. And let's assume that you just use one particular Terraform project. Okay. There can be hundreds of development teams, but let's take example of only one development team. Okay. Even for one development team, as a DevOps engineer, you might create a lot of resources, right? Just one single development team can use VPC, EC2 instances, they might use load balancers, they might use EKS clusters, Lambda functions, S3 buckets, everything that we have learned as part of AWS Zero to Hero series. Now, if you try to put all of these things in one single Terraform project, I'm not even talking about multiple development teams. I'm only talking about AWS DevOps engineer supporting one particular development team. If that particular DevOps team creates only one Terraform project, okay, if you create only one Terraform project for all the requirements of this development team, let's call this development team as XYZ development team. So your Terraform project will increase leaps and bounds. That means your Terraform project will end up similar to this monolithic application, because you have everything in one particular Terraform project. So to solve this problem and to address all of these challenges exactly the same, let's say you created the Terraform project and you found bug in the Terraform project that you have created, right? How will a new person understand where to go? Who owns that Terraform project? Because that Terraform project would also have some thousands of lines. Of course, it will not have millions of lines, but there can be some thousands of lines. And how do you maintain this particular Terraform project, right? And finally, how would you test it? Again, this is very, very important, because let's say you created a particular Terraform project, and in the main.tf file, okay, in the main.tf file of the Terraform project, you wrote logic for all of these things, right? And you want to fix a bug with respect to EC2 instance. So one of the DevOps team member, okay, would create a pull request on the GitHub repository addressing changes for this EC2 instance, but it is in the same main.tf file. Probably you are making some changes to the variables, okay, and to test if this variable has impact to the other things or not. Or sometimes this can become very, very tricky. Some of the components can be interrelated, okay. You might be using same subnet for different resources. So it is important to not create everything in one single thing. And here developers are following an approach called microservices, whereas as DevOps engineers, with respect to Terraform, you will follow an approach called as modular approach, or this particular concept in Terraform is called as modules. So don't worry, I'll explain you how to use these modules, what exactly these modules are. If you have an existing Terraform infrastructure, how to convert that particular infrastructure to modules. We will learn about all of these things, but here you need to understand this particular concepts, because they can be asked as scenario based questions, or during the theory part of your DevOps interview, you might be asked these questions. So that's why what I've done is, apart from these things that I've mentioned, you can also go to the GitHub repository, and in the GitHub repository, you will find a document called modules.md. And here I have mentioned about the reasons. So what are the reasons? One is modularity, which I've talked about. Second is reusability. Of course, the advantage of the reusability in this case would be, let's say that instead of writing this entire thing as one single project, if you write EC2 as a module, okay, you will get the ownership for one particular DevOps team member. You will get the maintenance done very easily. Along with that, let's say there is another particular development team called ABC, and they also need logic for EC2 instance creation. So what you can do is, you can use this particular module that you have written, okay, to the development team ABC and XYZ. Right? If you write it as one single Terraform project, everything in the main.tf file, and if XYZ team and ABC team, like XYZ team, they have requirement for EC2 instance plus VPC plus blah blah blah, and here they just need, for example, only an EC2 instance. So if you are modularizing this particular Terraform project, out of all the things that you have written for them, you can just take the EC2 instance code and you can utilize for the ABC team, right? So that is called the second thing, which is called as reusability. Simplified collaboration, which we talked about, versioning and maintenance, abstraction, testing, documentation, scalability, security, which we discussed, right? When I explained about microservice architecture, I covered about all of these things. And you can also go through this entire MD file so that you can be ready for your interviews and you can explain them what are the advantages. Now, let's try to put these things in action. Like I told you, we will do the demonstration. And as part of the demonstration, firstly, I would create a Terraform project with the things that we have learned as part of day 2. That means I'll create a proper Terraform project using variables, using TFRs. We will create resources on AWS, and then we will learn how to modularize it. Okay, so let's get started. For the purpose of the demonstration, I will use code spaces. I have explained in the first video, how to create code space, how to configure it, how to set up Terraform and AWS. And it comes with 60 hours of free time. So I thought I will utilize it, and people who don't have proper resources, it will be easy for them, right? So that's why I'm doing it in the code spaces. And firstly, what I'll do is I'll just show you that Terraform hyphen version, Terraform is properly installed. Then AWS hyphen version, AWS is okay. The Terraform spelling is wrong. AWS is installed, and now let's see Terraform as well. Terraform hyphen version, it is also installed, right? And let me delete if there is any Terraform infrastructure. So I'll use Terraform destroy, and you will see that there is no Terraform infrastructure that I have previously created. Perfect. Now let's switch to day 3. So what I'll do is in the day 3 folder, by the end of this demo, you will see the files uploaded. When you watch this video, all the project that I'm creating would be part of day 3. So let me create a new file here so that I'll start everything from the scratch. So firstly, I'll write this main.tf, right? And inside main.tf, what we will do is we will try to create a EC2 instance using all the concepts that we have learned in the last class. Okay. So first we will start with provider, and why you are seeing this particular thing here, why I'm getting auto suggestion, that is because I have used some plugins. So you can also go to your Visual Studio, click on the extensions button. I have explained this on day 1, but I'll repeat it. So search for Terraform. Okay, you will see something here called HashiCorp Terraform, right? This is the official one, HashiCorp Terraform. There are 3.1 million installations. So install this particular thing. And then there is something called HCL, right? Which is HashiCorp language. So I have also installed this. So using both of these things, you will get a lot of automatic suggestions, and you will see autocomplete feature as well. So if you see here, if I just write provider and click on this one, the entire indentation part is done, right? And here I just have to name the provider. I can just say the name as the name of the provider as AWS. And once you provide these details, if I just search for REG, you will see that the region field is auto populated. And in the region, I'll just provide it as US East 1. You will see how easy it is to write this entire Terraform project by using all of these plugins and extensions. And this is how DevOps engineers work in the real time, right? So DevOps engineers install all of these plugins, use Visual Studio Code or any IDE. Now, for writing the EC2 instance logic, first thing you need to do is you need to write the resource keyword, right? And in the resource keyword, you see here, because I'm using these plugins and extensions, it is showing me all of these things. I don't even have to go to the AWS official documentation for HashiCorp. So I know that I want to create an instance. So AWS_instance. See, I already got it. And let's name this instance as example. And inside the instance, if you don't know what needs to go into the instance, what you will do is you will just search for Terraform space AWS. And here you will go to the AWS provider, and you will have a wonderful documentation here, and just search for AWS_instance. Some of these things you will master with the experience, but sorry, where is it? AWS_instance. Yep. So here you can see what are the fields, right? You will see what are the mandatory fields. If you just scroll down, you will see the list of fields that are mandatory. There are fields that are optional, deprecated, and there are fields which are not optional, right? So you can scroll down and you can learn through this documentation. But for now, because I already know what fields are required for the AWS instance, let's write that. One is you require AMI. Within AMI block, you can choose a particular AMI, right? But in today's video, we don't want to hard code these fields, right? In the last class, in day 1, we have hard coded this using a particular AMI. But in today's video, we will variabilize it. So let's keep it here before I initialize the variables. And then what I'll try to do here is the next thing that is required is the instance type. So instance type, again, I'm not hard coding because I want to make this demo through variables. And finally, in my case, I need a subnet. That is because of my AWS configuration. I have modified the default VPC configuration for some other demo, and unfortunately I cannot delete that particular thing because I'm continuing with that demonstration for something else. So I need this subnet. In your case, you don't have to mention this. Okay. And if you provide these details, and if you just do Terraform init plan and apply, you will see an AWS EC2 instance will be created. And that's what we did as part of day one. Now let's use variables. So what I'll do is use the keyword called variable, and inside this write the name of the variable. So for AMI, I want to call the variable name as AMI underscore value. And whenever you are writing a variable, it is important to write the description for that variable, because anyone who is reading your Terraform project, they need to understand what exactly this variable is. So here I'll say value for the AMI. And here you can provide any default thing if it is required. Like you can provide what is a default AMI, but in this case, I don't even want to provide anything default. So let's avoid this. Perfect. And I will create another variable for instance type. Let me call it as instance type underscore value. And you need to mention the description. Value for instance type. And finally, let's use another variable for subnet. I'm repeating again. In your case, this might not be required. Subnet underscore ID underscore value. And just write the description for it. Value for the subnet ID. So I'm just writing some vague description. You can provide the description as precise as possible. You can write it in multiple lines. More you write about these variables, more it is understandable for someone who is reading the project. Perfect. So I have this bunch of variables. Now what I'll do is here I will replace this thing with var.ami value. Here I'll say var.instance type value and var.subnet ID value. So see, by using a IDE, that is by using Visual Studio Code and the plugins that I have mentioned, how simple is this, right? It has become so easy to write 20 lines of Terraform code. We just wrote without even referring to the documentation. So that's the power of using IDE and the extensions, right? And because I'm using code spaces, I don't even have to create a virtual machine, or I don't even have to bother about my personal laptop. Everything is configured here. Now, if you try to execute this particular project, what would happen is, of course, you have provided proper syntax for the provider. You have provided the provider configuration, you have provided the resource, you have all the variables created, but where are the values for the variables, right? There are no values for the variables. One is you can hard code these values. You can say that the default value for the AMI is AMI hyphen XYZ something, which is fine. But in organizations, usually there is a approach of assigning these variables, that is by using the tfvars file, right? Now there are bunch of advantages if you use this file called terraform.tfvars. The advantage is that, if you are providing any default value here, one is, let's say someone forgot to pass the AMI value, right? Using the Terraform command, when they are running Terraform apply, they can say hyphen var, they can provide this variable name and they can pass this variable name, or through any other ways they can pass this. But if you are using this tfvars, the advantage is that you don't have to check in this tfvars file to your source code. Like you can ignore this tfvar file to your GitHub repository, and you can say that if there is any sensitive information, for example, here all of these fields are not so secure. Let's say you have some sensitive information which you don't want to reveal to any other people. You don't want to push such information into a GitHub repository. Even such things, you can put this in the tfvars, and you can say that anyone who want to execute this project, they can create their own tfvars file. I'll show you in a minute, you will understand. So I'll just say AMI value is equals to, in the string, I need to go to AWS console for this. I'll get a AMI value. So I already have 2 instances that are running. Let's create, 2 VPCs that are there. Now let's search for EC2. I am just trying to get a AMI value. Click on the instances, click on launch instance, and you can get the Ubuntu AMI value from here or any other AMI. Let's say Ubuntu, and copy it from here. Of course, you can get AMI values in the other way as well. So this is AMI value, right? And then let's move towards, where is this? Sorry, yeah, main.tf instance type. Oh, instance type value is equals to T2 micro, because it comes with, I mean, this is under the free tier. And then subnet ID value. See, I did not even enter subnet ID value completely, but it is auto populated. And in the subnet ID value, what I can do is I can open VPC configuration. This is again only for my setup because I am doing some other thing. In your case, you can ignore the subnet ID. Still, you can create the EC2 instance, right? Let's go to subnets directly and provide one of the subnet details. And if you want to pass any other fields such as key value pair or any other thing, you are feel free to pass that value to your EC2 instance logic that you are writing. What happened? VPC, and within the VPC, I have subnets here. Sorry for this. It's taking a little more time for loading this page. So this is one of the subnet I'll take. So now what will happen when I execute this Terraform project? Like when I use this command called Terraform apply, what will happen is Terraform will automatically look up for this tfvars file. It will understand that, okay, I have to replace these fields, right? AMI value, what Terraform will do is before the execution, it will apply this variables with the values that are in the terraform.tfvars. You can change this name. You can call it dev.tfvars. But if you are doing that, you have to pass that to the Terraform apply command, because by default, Terraform will only look for this particular name called terraform.tfvars. Okay. So this is one of the advantage, that is automatically Terraform will pass this value. Other thing is, let's say for some other project, or let's say that there is a developer XYZ person who want to run this Terraform project. They can simply come to this tfvars file and they can modify it. Or if you are not pushing these things in your documentation in the GitHub repository, you can just tell that particular developer to create a file called terraform.tfvars, and in that file, update these 3 values. Okay. In such case, what will happen? Even if there is any sensitive information, let's say you have information such as access key ID. Okay. You have your AWS access keys, or you have IAM related policy information. All those things, you don't have to check into your GitHub repository, and you can tell them that, okay, create a file like this and update your details. Perfect. So now let's try to execute this thing and see. So, okay, another thing what I'll do here is, you might have understood till now what I've written. Now let's take this entire thing. Okay. And I will create a different file here, which is called as variables.tf. .tf. Now what I am doing here is I am writing this entire Terraform project in a proper structure. Instead of just writing the entire code in the main.tf, I am creating files for variables. I have created variables.tf. For tf vars, where I am passing the values, I have created a different thing. And this is how you have to write things, right? Even in an interview, if your interviewer is asking some questions, this is how you have to write. And in the main.tf, I've written this. If you still want to segregate this, for provider, you can create another file called providers.tf and you can update there. But for now, it's fine. Now, let me try to initialize it. Terraform init. Oh, sorry. I need to go to day 3 folder, right? Wherever the Terraform project is, you need to go to that project and then call it as Terraform init. Okay, what is it doing? Initializing the backend. Then it understood that your provider is AWS. Now let me do Terraform plan. Always do the Terraform plan because you will understand what exactly you are going to create before applying. So it is saying one resource to add, and see here carefully, the subnet ID is replaced with the value that I passed. Instance type is replaced with T2 micro. AMI ID is replaced with the AMI that I'm using. So what Terraform did is, Terraform, when it has initialized, it understood that you are using TF vars and it has replaced these particular values with, replace these variables with these particular values here. Perfect. Now let's try to run the Terraform apply. Terraform apply. And it will ask you, it will give you a prompt for yes or no. And you can mention yes. And you will see that a EC2 instance is created, right? So I have used variables, I've used provider, I've used resources, all the concept, but one thing is left to use, that is output. Okay, I told you in yesterday's class, we can also use the concept of output and print whatever we require. What does that mean? I'll show you in a minute. Now, once Terraform completes the creation here, you will notice Terraform will just tell you that, okay, the input that you have given is created, the project is successful. But what if, as a DevOps engineer, you wrote this entire code for one of your team members? Okay, you wrote this entire thing for one of your team members, and let's say that developer or QE has executed this project and they will just see this particular output. What does the output say? Apply complete, resource 1 created, 1 added, 0 changed, and 0 destroyed. But what is created? What is the public IP address of this EC2 instance? Let's say they want to understand that, because they don't want to again come to you and say that, hey Abhishek, can you go to EC2 instance? I don't have access to it. Can you go to the EC2 console and tell me what is the public IP address? You don't want to get into those things, right? So you see that a instance is created, right? This is the particular instance. There is only one particular instance here. The other thing, okay, so this is the one that I've created. Other thing I might have previously, I might have created manually, but this is the instance, let's say, that is created. Now, there is no information for the person who has executed the project. So how you can fetch that? So for that, you will use a concept called as outputs in Terraform. Let's see that again. So what I'll do is I will destroy this particular project and I will add output field, and I will show you how, instead of just saying apply complete one resource added, you can also get the information of the resource that is created. Okay. So it is asking to delete. I'll give the permissions to delete, right? It is deleting this particular instance called 0dd. This is the particular instance it is deleting. Okay. It is not yet initialized. My bad. I thought this is the one that is created, but no problem. So this particular instance would be deleted. Now let's go back. Let's give it a second to delete. Still destroying. Okay, meanwhile, I'll show you how to write that particular outputs.tf file. So again, I'll go to the day 3 folder, and inside the day 3 folder, I'll create a new file called outputs.tf. Perfect. And here, what I am going to do is I will write output. What is the name of the output that I'm looking for? Let's say I want to get the public IP address. Okay. You can give any name. And here you need to write the value that is required. So value is equals to, how do you need to write is AWS instance, like you need to provide the name of the resource. And once you provide the name of the resource, you will see that it is auto populating. If you don't have the Visual Studio Code setup, then you need to write this AWS instance dot example. But in my case, I don't need to write because it is auto populated. I'm just using it. AWS instance resource dot resource name, followed by what you will try to print. You have all of these options which you can print. Okay. But I want to print the public IP. So I'll just select this option. If you don't know how to print the public IP, here in my case, because I have the setup, I'm just going through this list and I'm just trying to print the public IP. But if you don't know that, you need to go to the documentation and you need to learn about this particular thing. Now, if I go back to the AWS console, let's see if the instance is deleted because it said it destroyed. Perfect. It is destroyed. Now let's try to create another instance. This time, when I run the particular thing, it has to give me Terraform init. Terraform. I'll not do the apply one more time because I haven't changed anything. So I'll just say Terraform apply. But it's always a good practice to do Terraform plan. Okay. In your organization, when you're working, please don't miss to do Terraform plan. So it is saying one changes to the output where I get public IP address. Now I don't have to delete the infrastructure. I don't have to destroy it. But only reason why I've done it is just to show you people, right? But instead I could have just added the output.tf and I can just re-execute the project. Still it would have given me that. But just to show you from scratch, I've done it. Okay. Now within a minute, you will notice that along with the apply message, you will also see the public IP. Okay. So this is how usually you need to write a Terraform project. See here, one apply complete, one resource is created, and in the output, it has given the public IP address. And you can print n number of resources, whatever you would like to. Done. So this is how you write a project in your organization using all of these things. Now, if you go to day 3 folder, you will, let's close these things. These are the provider information, log file information. For now, ignore those things. What are the important files here for now? The main.tf file that I've created, output.tf, state file. We all know what is a state file. It records everything that it is created, that it has created on the cloud provider. Then we have tfvars and variables.tf. Now let's try to modularize this project. Now, why you need to modularize? You might be thinking, but Abhishek, this is a very simple main.tf file. Now, what if I have 100 resources? Okay. Along with this particular resource, let's say I have a resource for S3. Okay. Let's say I have resource for EKS. I have resources for n number of things, the VPC configuration, everything in the same TF file. Luckily now, this is a very simple project. So in such cases, you have to modularize. If you are not modularizing, I have explained what are the drawbacks, right? You will write the same thing for 10 different development teams. That is not a good practice, right? So to modularize it, what you will do is in the same folder where you are writing the Terraform code, just create a new folder called module, or you can call, like, you can provide any name of the module. Like what I'll do here is I'll call module underscore EC2 instance. Let's call it as modules underscore EC2 instance. Okay. And now what I'll try to do simply is I will move all of these files under modules underscore EC2 instance. Okay. So just move the main.tf to the modules underscore EC2 instance. Of course, I'll make some changes, but let me quickly move and show you. Outputs is moved, tfvars is moved to modules, and finally, I'll also move the variables.tf. Okay. Now, what I've done is everything is under the modules folder, and inside the modules, everything is under the EC2 instance. But I don't have a main.tf file, the proper main.tf file. The main.tf file is available in the module, right? In this module, now you have everything. But let's say I will delete this tfvars file, because whenever you are writing a module, you don't have to write tfvars. People who are executing the modules, they can get the tfvars. Okay. So in the main.tf of the module function, module code, I have that I want an EC2 instance, and I have provided what should be the output, right? In the variables, I have defined the variables. Now, any project, any member in your organization, what they can do is, they don't have to write it inside the day3 folder. It can be in another GitHub repository. Anybody can simply create a new folder called, a new file called main.tf. Okay. And in this main.tf, what I'll simply write is provider, AWS, region, AWS East 1, US East 1. Now, meanwhile, let me also delete the Terraform infrastructure, Terraform destroy, so that I want to execute it using modules and show you. Perfect. While it is deleting, let's proceed. And here, instead of resource, what I'll say is module. Okay. What is the name of the module? You can call it as, let's say, EC2 underscore instance. And here comes the important thing. You have to tell Terraform where it has to fetch the module from. If the module, in this case, the modules is just in the modules folder, EC2 instance. So this is the folder. But if it is in the GitHub repository, in a different GitHub repository, you have to provide that. Whatever is the path, you have to provide the path for the module. In your case, because we are just modularizing the application, this is in the same folder, right? Under day 3, you have this module folder, but in your organization, this entire folder can be anywhere else. And when you are executing the modules, either you can create tfvars file, or even here you can pass the values that it has to execute on this module, right? So here I'll just tell that pass these things to the module. AMI value. Oh, I deleted that file, so I have to refetch these things. But I'll show you AMI value, and the next thing would be, what was the next thing that we have done? Instance type value. And finally, the last one is subnet value. Okay. Now, let's try to replace these things with the actual ones. So if you just go to this instance ID, can I fetch the AMI details here? Yes. You can take any AMI. I'm just randomly taking it. Okay. Instance type value, t2.micro. And you can pick up any subnet value here. Just for the easy purpose, I'm trying to collect this information from here itself. Okay. Now, before I execute this module, let me go to the EC2 tab, and let me show you that I refreshed. Everything is getting terminated. There is only one instance that is running. This is a previous instance that I have, right? You can see the name 7431. This is a previous instance. Perfect. Now, what I have done here is, instead of writing the entire Terraform code, right? Now, let's say you are another DevOps engineer, and someone has created this module entire thing in their own folder, right? What you are doing is you are just writing this simple main.tf file, and you are referencing the module that other person has written. But you need to have knowledge on the module that person has written, right? You need to know what is the location of the module. So this is the location of the module, and in that module, in that location of the module, you have main.tf file, where it is creating an EC2 instance with these fields are required. That is, AMI is required to be passed, instance type is required to be passed, and subnet is required to be passed. And those things I will try to write in the main.tf file. Okay, so I've written those things in the main.tf file, and now let's try to execute and see. Terraform init. So what is the advantage that we gain here is, next time when someone writes, okay, that person might be writing in this GitHub repository, another GitHub repository, another organization, another GitHub organization completely. What they can do is they can just write this simple code instead of writing the entire thing that we have written in this folder. They don't have to write this particular main.tf. They don't have to write the outputs.tf. They don't have to write variables.tf, tf-vars. Nothing should be written. They just need to know how to write this particular block of code. Now let's try to execute Terraform plan. Okay. So it said one resource will be added. Perfect. Now let's try to say Terraform apply. Now it will ask for yes or no. Let's say yes. Now you will notice that because we are consuming this module, the instance will be created. Okay, so 100 members can execute this particular project, 1000 members can execute this project without writing all of these files. They just need to write this simple block of code. So using the modular approach, you are developing reusable code. You are developing easy maintenance, right? Only thing that you need to maintain is this block of code. If this piece of code is written 1000 times, no problem, because there is nothing here, right? Everything is in this particular module folder, and you can simply maintain this module folder instead of maintaining 1000 projects. See, it said the instance is created. Let us see if the instance is created or not. You should see 2 instances in running state. See, the new instance is created. So this is how you modularize applications. So if you have, let's say, instead of, in the previous example, when I explained, I just used one particular resource, right? Here I just used one particular resource. What if you had 2 resources? So you can create 2 modules. There is no problem. For AWS instance, you have created a module. Similarly, in this module folder, you can create a different GitHub repository just for the modules. There is no problem. You can create a GitHub repository called Terraform modules, and in that you can keep writing all the modules that you want to use in your organization. As a DevOps engineering team, you can do that. For EC2 instance, you can write a module. For VPC, you can write a module. For EKS, you can write a module. And you can just tell the developers that, okay, developers, we have written entire thing for you. All the modules are automated. Now what you need to write is simply a main.tf file. And in the main.tf file, just call the modules that we have written and just pass the values. Okay, you can provide them some documentation and tell them that these are the values that you need to pass. Perfect. So this is how you modularize your infrastructure, your Terraform infrastructure. And please go through this notes one more time. And what I will do is I will publish these things, whatever the project that we have created. I will put this entire thing in the day 3 folder. But please try to do this entire thing on your own. If you just try to execute, if you just go to the day 3 folder and execute it, definitely you will be able to run it. But just try to repeat the exercise that I've done. Even though you know about modules, let's say you have worked on modules long time back, still try to do that so that you will just try to brush up your knowledge. Okay, so that's all I have for today's demo. Sorry, one thing I forgot. Now, when you are using Terraform Cloud, or let's say you want to use any publicly available modules, what does that mean? Similar to Docker Hub, if you know the concept of Docker images or container images, you all know that there are some publicly hosted images in Docker Hub, right? So this has publicly hosted images and anybody can use it. But technically in the organization, you will very unlikely to use the publicly hosted images because you don't know who are maintaining them. You might create your own images. You can push them to your private image registries and you will use from there. Similarly, for Terraform also you have something called as Terraform registry. You can just search for Terraform registry, and here you have bunch of modules, right? You can just search for EC2 instance. You will find modules similar to what you have developed. Okay. So this is AWS EC2 instance state, but similarly you will find Terraform AWS EC2 instance module as well. It is up to you. It is up to your organization if you want to use this publicly available modules. To use the publicly available modules, it is very, very simple. Let's say you want to use this particular thing called underscore instance. Okay, so this is one of the Terraform module for EC2 instance. And if you just go to click on the example button, click on complete, you have the code here, right? You can just come here, copy paste this thing. Anybody can use this particular module, but this is publicly available. So you are not sure if there is any issues. So you have to use it on your own at your own risk. So instead of doing that, what most of the companies do is they write their own modules. Okay, just like I have written now, companies, DevOps engineers, they write their own modules and they put that in a GitHub repository. That will be a private GitHub repository. Right now we are using a public GitHub repository, but usually people use a private GitHub repository, and from there they will reference the modules. Exactly how I have done, right? Just provide the module path. If it is in the same GitHub repository, use dot and provide the path. If it is in a different, you have to provide the complete path. Got it? So I hope you found today's video informative. Thank you so much for watching the video. And in future classes, we will learn about Terraform state. We will learn about a lot of interesting aspects about Terraform. Stay tuned. Thank you so much. Take care, everyone. Bye-bye. Hello, everyone. My name is Abhishek and welcome back to my channel. Today is day 4 of Terraform Zero to Hero series. And in this video, we will deep dive into the concept of Terraform state. Let's check the GitHub repository to understand the detailed agenda for today. So firstly, we will start with understanding what exactly is a state file in Terraform. What are the advantages that Statefile brings into the Terraform project? Along with that, we will also understand about the disadvantages that Statefile creates with respect to version control system and handling the sensitive information. However, to solve this problem, there is a concept called Terraform backends. So we will learn about Terraform backend to address the above two challenges. After that, I will show you through the demonstration how to implement this Terraform backend on the AWS environment. We will be using S3 bucket as Terraform remote backend. Finally, we will also learn about statefile locking. Why is statefile locking important and how to implement the statefile locking using DynamoDB. So these are the concepts that we are going to learn today. And this will cover a lot of scenario based interview questions related to Terraform. Look, so please watch it till the end. So let's start with understanding what exactly is a state file in Terraform. So I can say Statefile is a heart of Terraform because using Statefile, Terraform will record or it will store the information of the infrastructure that it has created. What does that mean? So let's say you wrote a Terraform project, and in the Terraform project, you wrote the logic for EC2 instance creation. So you said that I want to create a EC2 instance with instance type of T2 micro and AMI ID XYZ something. And you executed the Terraform apply. Now what Terraform would do is it will take this information and it will create a EC2 instance along with the information that you have provided. Let's say you have also provided the name of the EC2 instance. So it will create this EC2 instance with T2 micro, AMI ID, and the name that you have provided. Let's say the instance name is Abhishek. Along with this, what Terraform will do, along with creating the resource, Terraform would also store the information in a file called Statefile. In the Statefile, Terraform would store that, okay, I just created a EC2 instance with the name Abhishek, with the instance type, this specific thing, instance ID, followed by the AMI details that you have provided. Now, what happens if Terraform did not store this information? You can ask this. Abhishek, you are saying that this is an advantage that using Statefile, Terraform records this information. But what happens if there is nothing called Terraform Statefile, or Terraform does not record the information? What would happen is, let's say 5 days later, you want to modify the EC2 instance that you have created. Let's say along with the name of the instance, instance type, and AMI ID, you want to create a tag for this EC2 instance. Okay, so of course you can go to the UI and you can update the EC2 instance in the UI, but this is a wrong practice. The reason why we are using Terraform is we want to use Terraform to automate the infrastructure. That means everything we want to do through Terraform, and you don't want anyone to access the AWS UI. So you will go to the Terraform block, the EC2 instance block, and here along with the name, instance ID, and AMI, you will also update the tag. Now, if there is no state file, Terraform will not understand that it has already created an instance with name Abhishek. So what it will try to do, it will again take this information when you run the Terraform apply, and it will proceed to the EC2 instance API, and it will try to create one more instance with the same name called Abhishek. Okay, of course the instance ID will change, or if you provide any other details, like here you have provided the tag, so one more instance would be created with name Abhishek and there would be a new tag. But this is not your expected behavior, right? What you wanted was Terraform should update the EC2 instance that it has created. So that is where Statefile comes into picture. If Terraform has a Statefile, of course it has a Statefile for this own purpose. That means whenever you execute Terraform apply, okay, or whenever you execute Terraform plan, what Terraform will do is, before applying, it will go to the state file and it will check in the state file what is the infrastructure that it has already created and what is the new infrastructure that it has to create. Okay, so what is created and what it has to create. So using the state file, it will compare the difference, and if the difference, in this case, what is the difference? Previously it has created EC2 instance with instance name, type, AMI, so it will have all those details here, and what you are trying to create, the only difference is the tag. So Terraform will just update the tag, right? So how did it come to know that it only has to update the tag? Using the concept of state file. So that's why state file is heart of Terraform. If there is no state file, Terraform will never come to know that it has to update infrastructure rather than creating it. The same applies to delete as well, right? Let's say you want to delete the particular instance. Okay, you executed action called Terraform destroy. Okay, now Terraform has to inform you what it is destroying. It will take confirmation from you that Abhishek press yes. So it will give you a bunch of information, right? This is what I'm trying to destroy. How will Terraform come to know? Again, it will use the state file. In the state file, it will see that when you run the Terraform destroy command, okay, this is all what I've created. I understand from the state file. And now let me provide this thing to the user and say the user that, okay, this is what you want to delete, or this is what you want to destroy. So if you are okay, press yes, right? So finally, what I wanted to tell you here is state file is useful. It will record the infrastructure that it has previously created. It will help if you want to update existing infrastructure, or even if you want to destroy the infrastructure. Using state file only, Terraform will come to know what action it has to perform. Perfect. So these are the advantages of using the state file. Now you might ask me that, Abhishek, but this is looking super cool. When Terraform state file is this good, why did you say that there are some disadvantages to the statefile? Let me explain you. Of course, there are disadvantages with Terraform statefile. You can address them. So you cannot call them disadvantages, but you can call them as drawbacks. But these drawbacks can be addressed. So what are these drawbacks? So the first thing is, like I mentioned you, any action that you perform with Terraform, okay, whether you want to create EC2 instance, whether you want to create S3 bucket, you want to create EKS, you want to create any policy, or you want to create a you know SNS queue or something. What Terraform does is, irrespective of what you are creating, it will take this information and record in the state file. Now, what if you are trying to create something that is sensitive? Okay, in the resource creation logic, what if there is some information you don't want to store in the state file? By default, Terraform does not do it. What Terraform does is, Terraform will record anything. It can be sensitive information. That means it can be a password, it can be anything. Irrespective of that, Terraform will store this entire information in the state file. That means whoever has access to the infrastructure where you are storing the Terraform project, let's say I'm using my personal laptop. Okay, and in my personal laptop, I am storing this Terraform project, the Terraform files that I'm using to create the infrastructure, which is very unlikely. Nobody will store this in the laptop. I will go to the next step. But for now, let's understand that I am only one DevOps engineer in the entire company, and I'm storing this entire thing on my personal laptop. And I've created this Terraform logic, and it stored the state file on my machine. Okay, and what will happen is, this state file, if there is any sensitive information, it will also get recorded. So this state file is sensitive. You might be thinking, what does sensitive mean? Anything related to secrets, passwords, API tokens, anything. Like when you create instances on AWS, there will be a lot of resources, right? So my laptop now has a state file that has some sensitive information. Because it is my personal laptop, nobody would access it. There is no problem. But this is not how real world would look like. In real world, you will be a team of DevOps engineers, and you write this Terraform project for bunch of developers as well. That means you can write this Terraform project, okay, and you can hand it over, or you can give this Terraform project to development team and tell them that, okay, as a DevOps engineering team, we have created the project. Now, whenever you want to create S3 bucket, just execute this particular project. Or whenever you want to execute a EC2 instance, just run this Terraform project, right? So if you give them this particular instance access rather than your laptop, if you create a EC2 instance, and in the EC2 instance, let's say you have installed Terraform, you have installed AWS CLI, and in that EC2 instance itself, you are writing your entire Terraform project logic. And if you give access to the development team, one of the developers can go to the state file, and that developer can read the state file. If the developer reads the state file, that's it. They will access what is there in the state file. The other scenario, and this is the most common scenario, what you would do, instead of storing in an instance, usually DevOps engineers would store commonly written logic in GitHub, Bitbucket, or any Git repositories. Why? Because DevOps engineering team is not just one person, it is group of people, right? So to collaborate on a project, what you will do is, you will store the code in a version control system, right? That version control system can be Git, GitHub, Bitbucket, anything. So you will store the entire Terraform logic in a version control system. And if this version control system is compromised, that means along with the Terraform project, if you are also uploading the state file to the version control system, what would happen is, people who have access to this GitHub repository, probably they can be your organization people itself, but they will see the state file. You might say that, Abhishek, but I will restrict my GitHub and I will not allow anybody to access the state file. Okay, let's say you have done it, but there is another problem as well. Okay, let's say you have restricted and you have not given access to anyone, only your DevOps engineering team. Okay, let's say you are DevOps engineering team of 5 people. So you have created a GitHub repository for this particular 5 people, and only 5 people has the access to GitHub. And there you pushed your entire Terraform project. It can be for 100 resources, 1000 resources. You have created separate folders or you have created separate modules, and you have stored it in this particular GitHub. And nobody has access. So you will say that I'll also push the state file, so I don't have any problem. Someone checks out this GitHub repository. Let's say there is one DevOps engineer who wants to modify this Terraform project. So what this DevOps engineer will do is this DevOps engineer will download the GitHub repository, and this DevOps engineer would modify the infrastructure. Let's say adds a tag for EC2 instance and executes the project. Okay, and EC2 instance is updated with the particular logic, and this logic, let's say DevOps engineer, the tag creation logic pushed back to the GitHub repository. Perfect. And state file is also updated for the tag. Along with pushing the code changes, DevOps engineer every time has to take care of pushing the state file as well, right? But the state file is only created after the applying of configuration. Before applying configuration, the state file is not created. So the problem is that what if DevOps engineer checks out the code, okay, updates the tag creation logic in the EC2 instance and checks back the code. The DevOps engineer, let's say, is not testing the configuration or is not updating the configuration, but just updates the code. Okay. So the problem is that because the state file is not pushed, Terraform will not know that the tag creation logic is updated. And next time when someone checks out the code, they will see the tag creation logic as the difference in the Terraform state file, and Terraform will ask you to delete that particular thing, and they will delete it. So this is another challenge. That is, if you are using the state file in a version control system, one of the problems is anyone who has access to this GitHub repository, the information, the state file information is compromised. And the other thing is, every time a new DevOps engineer makes a code change to the project, along with the code change, okay, along with the code change in the Terraform project, that particular DevOps engineer should also execute the code change and update the state file in his local and push the state file also to the version control system. And if someone forgets, if any DevOps engineer forgets, then your entire configuration is messed up. And it is quite possible, right? We are all human beings. So sometimes, you might have made the code change, you created the merge request or pull request to your team members, and they approved the merge request or code request, and the state file is not updated. So this is another problem. Two problems we discussed, right? The first problem is if your GitHub repo is compromised, then your state file is compromised. Second problem that we discussed is every time someone checks out the code, then they have to check out the code, update the code. Along with that, they also have to update the state file. But how to solve this problem? Abhishek, you said about advantages of state file, which is very good. Terraform is making use of state file and it is understanding the difference. You also mentioned about the drawbacks. I'll not say disadvantages. I'll say drawbacks, because these drawbacks can be fixed. How these drawbacks can be fixed? So Terraform has a concept called remote backend. What does remote backend mean? So here, remote backend means that Terraform provides an option that, okay, if you have this particular challenges of storing the Terraform state file in a Git repository, what you can do is you can store the Terraform state file in external resources. Let's say you can store the Terraform state file in a S3 bucket. And you don't have to bother about the state file in your local. What does that mean? So in Terraform, if you configure something called as remote backend, instead of state file getting created on your laptop or on your virtual machine, right? Instead of state file getting created on your laptop or your virtual machine, the state file would be created on the S3 bucket. If you are using S3 bucket as the remote backend, what would happen is that the S3 bucket will host your state file. So how would this solve the problem? If the state file is hosted in the S3 bucket, you don't have to bother about the two problems that I have discussed. One is you can completely restrict the S3 bucket access, right? You can say that nobody in the public can access your S3 bucket. And of course, it is in your AWS organization. You can configure it with IAM rules and policies. So one is your state file is extremely secure. And second thing is you don't have the problem that DevOps engineer checked out the code from the GitHub repository, let's say, and once he checks out the code, he made some modifications. Okay. He executed, he made the modifications and he ran the Terraform apply. Okay. Now, even if the DevOps engineer pushes only the modification, that means DevOps engineer push back to the Git repository only the code modifications, there is no problem, because as the DevOps engineer applies the Terraform configuration, or when the DevOps engineer runs Terraform apply, automatically the state file is updated in the S3 bucket. If the state file would have been updated on your local, that means if it would have been updated on your EC2 instance or on your personal machine, along with the code modifications, you should have pushed the state file as well. But here, if you are using remote backend logic, the state file is automatically updated when you run the Terraform apply in the S3 bucket. So your state file is not along with your Terraform project, but it is in some other place. And when you run the Terraform init, right, you must be thinking, but Abhishek, if the state file is somewhere else, what would happen if I run Terraform apply? No problem. Whenever you execute the Terraform init command before running Terraform apply, immediately Terraform will understand that, okay, this person is using the logic of remote backend and my state file is in the S3 bucket. So let me get the information from there. And now from your project, Terraform will understand, okay, this is what you are trying to do. So now Terraform compares the diff between the S3 bucket and the GitHub repository. Previously, it used to compare the state file in your local and the GitHub repository logic. Now what it will try to do is it will compare with the state file in the S3 bucket and the code in the GitHub repository. So for Terraform, there is no difference. But for you, the difference is that you are using S3 as your remote backend, which is making things more and more secure for you. And this concept is called as remote backend. There are so many remote backends. S3 is one such example. If you are using Terraform Cloud, okay, if you are using Terraform Cloud, you can host your Terraform remote backend in the Terraform Cloud itself. Let's say you are using Azure. You can use Azure storage for hosting your Terraform backend. So there are multiple remote backends that are available. So there is no problem. It is not only S3 bucket. So there are multiple options, right? I hope you understood the concept of remote backend. Now, how will you explain in your interviews? Okay, let me quickly explain. So what you will tell in your interviews that, let's say we are a DevOps engineering team of 5 to 6 people where we have a GitHub repository. Okay, we have a GitHub repository that hosts the Terraform code, and that code will have AWS resource creation logic. So let's say we are using the Terraform project to create EKS, or we are using Terraform project to create VPC 3-tier architecture. And what we do is, instead of storing the state file in the GitHub repository itself, we will use S3 bucket as remote backend. Okay, that's how, if any of the 5 to 6 DevOps engineers, if any person wants to update the EKS or VPC 3-tier architecture logic, they can simply clone the repository on their laptop. They can make the changes. They will verify the changes using Terraform apply. And what they will do is, with these changes, they will raise a pull request back, PR back to the GitHub repository. And because they executed the Terraform apply command, this apply will update S3 bucket with the logic. What is that logic? It will update that, okay, this particular change is made, so I need to track it as part of the S3 bucket. Perfect. And once they raise the pull request, someone would approve, another DevOps engineer would approve the pull request, and now the new Terraform project is ready with the source code, that is the Terraform project changes, as well as the state file is updated in the S3 bucket. So this is the workflow that you have to explain to your interviewer. Okay, so I hope this is clear. Now let's try to implement this particular thing on our environment. Okay, we will use code spaces and we'll try to learn about it. So let's go to the GitHub repository, and what I'll do is I'll be using code spaces. So throughout this entire Terraform series, I'm planning to use the code spaces. One is because other people will get acquainted to it, whoever is watching this video. But if you want to use your personal machine, there is no configuration difference. You will be doing exactly what I'm doing on this particular demonstration. Only thing is I'm just using a different, you can consider that I'm using a different developer environment and you are using your personal laptop. Perfect. And if you want to learn how to configure this code space, please watch the initial videos. I've explained in day one how to set up code spaces and how to configure Terraform and AWS in the code spaces environment. Perfect. So now what I'll do is let me go here and create a folder. Let me close these things. And I'll create a folder here called day 4. Okay. And I'll upload the same thing so that you people can also follow it. Perfect. So day 4, I've created the folder. Now let's create a file. We'll start from the scratch. Okay. So firstly, what I'll do is I'll create a file called main.tf. Okay. And now I am implementing it without using remote backend. So firstly, let me do that. So for that, what I need to do is simply I'll say the provider AWS. Here I'll mention the region. And if you are wondering how these things are auto-populating, right? Everything that I'm writing, how it is auto-populating and auto-correcting. So I'm using some extensions which I've explained in the last class. So you can check what are the extensions. Typically the HashiCorp as well as HCL extension you can download, and then you'll get these features. Then I'll quickly write a simple logic for AWS underscore instance. See here, everything is getting auto-populated and I'm just copying it from them. AWS underscore instance. Let me call this as Abhishek instance. And here I'll just write instance type is equals to, there is no rocket science because we have been writing this Terraform same project again and again in this course. That is the reason why I'm writing it little faster. Whoever has followed this course from day 1, they will be able to write this because we are doing the same thing, right? Otherwise, I would have also referred the documentation, or I would have taken little more time. So coming to the AMI, what I can do is I can copy from the previous days where yesterday we learned how to write modules in Terraform. So let's take example from there. So yeah, this is where I'm just copying the details. You can ignore this part. Instead of going to AWS console, I'm just copying the AMI details. And in my case, I'll also use a different subnet. But for you, it is not required. Okay. So you can also copy these details from your AWS machine, sorry, AWS environment, but I've just taken it from the previous day. Perfect. Now this is the general logic that you will write for instance creation, right? So what you will do is firstly switch to the day 4 folder if you are using this particular repository, or if you are writing it in your personal machine somewhere, then you need to switch to the project where the main.tf file or the Terraform files are written. Now, if you see, if I do the ls, there is only one particular file called main.tf and there is no state file. For reading the state file, there is a command called Terraform show. See, it said that there is no state file. Now, what I'll try to do is I will try to run first Terraform init. Now, as I run Terraform init, you will see that here, let me close all the folders. there are a couple of files that got created. One is the Terraform log file. Now I'll explain in a couple of minutes why log file is required. For now, just understand that main.tf is the only file. If I do ls-a, you will see the log files as well, because they are the hidden files. Now let me run this command called Terraform apply. I am not running the plan command because I already know, we have been seeing from 3 days what would be the output. So let me not run it. So Terraform apply, and you will notice that a state file will be created. See, a state file in the day 4 folder, a state file is created. For now, the state file is blank because the apply command is not completed. Now I'll click on the yes button, and once the implementation is successful, see, I'm on the state file here. As soon as the instance is created, you will see that the state file will be populated. Let's wait here. See, the instance is getting created. It is saying created. As the resources are creating, once they are created in the AWS, you will see things reflecting in the state file. Perfect. 10 seconds more, and you will see the EC2 instance created and the state file updated. Still creating. Perfect. Instance is created and the state file is updated. What did it say? State file said that these are the bunch of resources. In the resources, it said that, okay, it has created instance, and this is the instance configuration. Let me increase. So this is the instance configuration. It has instance ID, right? It has all the fields related to the instance. Perfect. It has the public IP, private IP, everything is available in the state file. And why do we use output variables? If you think that, okay, Abhishek, here state file is already having all of this information, then why I need outputs? Outputs is required because if a developer is executing this Terraform project, they will not have access to the state file. Your state file will be very, very sensitive. So you will not provide the access to the state file to everyone, right? That's why you need to write the outputs.tf. Okay, that's a different topic. Now you see that the state file is created, and using this state file, Terraform records the entire information. Got it? Now let's try to modify this logic so that I will make this project a version control system supported. Right now, I cannot push this entire thing to the version control system because of the reasons that I've explained. You see, if I have to push this main.tf, and I also have to push the state file, which is wrong for 2 reasons. As I explained, one is it can have sensitive information. Other is I have to make sure that I push the state file. If someone forgets to push the state file, gone. Okay. So what I'll do is I'll delete this state file. First of all, let me show you the output of Terraform show. So Terraform show will give you the state file. You don't have to always go to the state file and open it. Here you can see the output of Terraform state file in a much better way here. Now what I'll do is I'll delete this state file. I'm deleting the heart of Terraform now. So delete permanently. Got it? Now Terraform will not understand if I just do Terraform plan and show you. Now again Terraform will say that I'm going to see, it has again created a state file, and it will tell you that I'll create one more instance. Ideally, what it would have told you, it should have told you that instance is already there, right? So perfect. Let me again go here, do the ls. There is no state file. Make sense? Let me close it. Am I in the right folder? PWD. Cool. Now let's try to use the logic of S3 bucket. That means let's use a remote backend as S3 bucket. For that, what I need to do is inside this day 4 folder, okay, along with the main.tf, what I have to do is I have to create a new file called backend.tf. In the backend.tf, I have to provide the backend configuration. Okay, what I need to provide? I need to provide the backend configuration, and to provide the backend configuration, I already know how to do it, but I'll not do it. I'll show you how to do it. Basically, you can just go to Terraform, search for backend. So this is the HashiCorp documentation. And here you will have the exact syntax. You can just copy it. Just search for S3. And this configuration is one-time configuration. You don't have to change it again and again. Okay. So this is the skeleton of backend configuration. And here I'll show you how to write the backend configuration for S3 bucket. Of course, it is also available somewhere here. If I click on available backends, click on S3. Yeah, see here, this is the configuration. I can simply copy it. And I keep on telling you, you might be an experienced DevOps engineer, but you will still copy paste the code because nobody will remember all of these things. And it is not of that use as well, right? You don't have to remember this all things as well, because that will not help you that much. So this is the backend configuration. So let's say you don't want to copy paste it. You can use Visual Studio extensions that I'm using, and it will auto populate the details. You can say Terraform. You can just write backend, and inside the backend, just provide what is your backend. So my backend is S3, right? So here, when you just click on the dot button, or when you just start typing, like either you can read from here. That means next I need bucket, next I need key, next I need region. Or what you can also do is, if you already know that particular thing, just type bucket, BUC, and it will give you. You need a bucket name. Then of course you need a region where this particular bucket is, right? And finally, what you need is, along with bucket and region, you also need, do I need key? Okay, I don't need a key, so I can ignore key for now. Key is required. Let's say that you want to add any particular prefix. Okay, let me add the key as well. Key, and in the key, what you can provide is, if you have any particular prefix to the folder. That means if you want to store in a folder called Abhishek in the S3 bucket. So in such cases, you can use. So here I can say Abhishek / Terraform.tf state. If you are a beginner, what you will do, instead of writing this like this, you will go to the documentation and you will copy paste it. Bucket, key, that is path to the key, and the region. I've provided all three of them, but I don't have a bucket itself, right? In my AWS configuration, let's say I don't have a bucket itself. So what you will do, firstly, you will create the bucket. Okay. So to create the bucket, you can again create the bucket manually, or you can create the bucket using Terraform itself. So because we have been talking about the configuration related to EC2 instance only, let me show you how to create a bucket. Okay. So in the main.tf, again, I'm saying this is not required. You don't have to do it through the Terraform same project itself. Either you can create a different Terraform project, or you can create this S3 bucket DynamoDB for one time manually. But let me show you here. Let me create the bucket. So for that, what I'll do is resource S3. Let me call this bucket resource as, what should I? This is just the resource name. This is not the bucket name. So let's say S3_bucket. You can put anything here, but the name, whenever you are trying to provide the name of the bucket, what has happened? So here I can also look at the bucket configuration, or I have it handy. There is some reason why this is not auto populating. Did I miss something? Yeah, I think it has to be AWS S3 bucket. Okay. So here the bucket name, let me provide, the bucket name has to be very, very unique because in S3 or in AWS, the bucket name is a global one. So let me provide a very unique one, call it as Abhishek-S3-demo. I'll just call it as XYZ. Okay, so that the bucket name is as unique as possible. So now if I execute this particular block, what would happen is, if I just say Terraform init one more time, of course here I don't have to, okay, let me delete the backend.tf file for now. Why I'm deleting it? Because backend is not yet available. So I can comment it out. rather than deleting it. What Terraform is trying to do is when I run the Terraform init command, it is trying to initialize and it is thinking that I want to use Terraform remote backend, and it is saying that you don't have a S3 bucket already. So that's what I'm trying to do, right? So AWS S3 bucket, and now if I just perform Terraform init, again I'm telling you, you don't have to do it through the same Terraform project. Just because we are learning Terraform, I'm showing you how to create a bucket. Now, if I do Terraform plan, you will notice that it will say, now your project will create an additional S3 bucket. Why is it saying two resources? Because the state file was not available previously. I deleted the state file. So now let's run Terraform apply. Okay. So now it will create S3 bucket for me. I need to say yes. Perfect. Once the S3 bucket is created, now what we can do is we can go to this backend.tf and we can uncomment these things. And here we can populate the things. Okay. What is the name of the bucket? Just remove here and copy this name from here. I'm just doing it parallelly. While the S3 bucket is getting created, I'll also populate these details. Region US East 1. That is the region, right? Yeah. So by default, my configuration will be on US East 1. So now next time when I execute, you will notice, see, this is created. Now if I go to my AWS console, you will see a S3 bucket with the same name, whatever I have created. Just go to S3. Perfect. In the S3, see a bucket with name called Abhishek S3 demo XYZ. And there is nothing in the bucket, right? Now let me go back and see the magic. What I'm going to do is I will delete this particular state file. I'm deleting the heart of Terraform, delete permanently. Okay. And now I will reinitialize this project. I'll say Terraform init, and the now state file will be changed to S3 bucket. See, initializing the backend successfully configured the backend called S3. And now if I just run Terraform apply, now what would happen is the state file will be created in the S3 bucket. State file will not be created on my local. See, it said two instances or two resources are getting created because it does not have a state file. It did not know that the resources are already existing on my, on my account. So it said two resources it will create. And if I just say yes, see what will happen is that it will try to create a S3 bucket. And of course, the S3 bucket is already available, right? So what will happen next? It will go ahead and try to create the instance. And after that, it will update the state file, not on my local machine, but in this particular S3 bucket that you will see. Let's wait for the execution to be done. Still creating. Sometimes this can be slow. It depends upon your network. It depends upon the latency, lot of other factors, right? So let's wait. So now the execution is complete, and you will see that inside the S3 bucket, there is a folder called Abhishek. And in this particular folder, there is a state file. Got it? So this is how you have modified your Terraform project to not to store the state file on your local machine, but to store it on the S3 bucket. And now if you perform Terraform state, it will read the info. Oh, sorry. If you perform Terraform show, it will read that particular information from the AWS S3 bucket. Whatever the resources that it has a track of, it will show from the S3 bucket. Perfect. So this way you will use the concept of remote backend. And now every time DevOps engineer makes code changes, let's say DevOps engineer wants to make code changes to the main.tf or any other file, what will happen? He or she has to only update this particular resource and don't have to bother about the state file. And no one will have access to the state file except for the people who have access to this particular S3 bucket. Now, one concept is left to tell you, that is locking mechanism in Terraform. Now, what is it? So you might have seen that whenever I am running the Terraform apply, or whenever I run the Terraform commands, first what Terraform does is Terraform will try to take the lock, or it will try to control the state file. Okay, so I've shown you a couple of minutes back, or 10 to 15 minutes back, that when I executed Terraform commands, you have seen that Terraform is taking hold of the lock file. It has created the lock file in the local, right? And it is trying to control the lock file. Why? Because what if you are a DevOps engineering team of 5 people, and let's say 2 people are trying to update the same project, and in the same project, one is saying that update the S3 bucket with bucket policy public, and the other person at the same time is saying update the bucket policy and expose the S3 bucket to only particular numbers. That is, one is trying to update the bucket as public, and the other is trying to update bucket as private. And for some reason, let's say both of them try to execute the Terraform apply at the same time. That can be, they can just download it, or they can run it through the CI as well. That means they can just run some Jenkins command, which can check out this GitHub repository and perform the action. What will happen? Which instruction Terraform has to take? Terraform will be confused. So that's why what Terraform does is every time it takes the control of the state file, it will lock the state file. So first, if I execute it, right, I will hold the lock on the Terraform state. Parallelly, if the other person is trying to execute, like, if both of us are doing in seconds difference also, only one person will hold the lock, and the other person have to wait till my execution is done. So what would happen in that case? I will update the bucket policy as public. Probably after that, someone will hold the lock and they will update the bucket policy as private. So locking mechanism is important, so that multiple people, if they try to execute the same Terraform project, only one person can do it at a time, so that AWS will not be confused and Terraform will also not be confused. For that reason, what you need to do is you need to maintain this lock somewhere, right? Because we are not doing it locally. Statefile is not there locally. There is a resource on AWS that is called as DynamoDB. So you can implement the locking mechanism using the DynamoDB. Okay. For that, what you need to do is in your backend.tf or in your main.tf, wherever you have created the S3 bucket, you can create another resource. Or again, I'm telling you, you can do it manually as well. Only reason why I'm telling you through Terraform is just that you will get acquainted to it. And here, what I'll say is resource. Did I miss something? Perfect. Resource AWS _ let me copy paste it. I already have the configuration. You can copy paste it from the documentation as well. So this is my DynamoDB configuration. Okay. What I'm doing is DynamoDB table. Okay. So here, this is the resource called DynamoDB table. We will use this DynamoDB table, and inside that table, we will say that who is the person who is holding the lock. So that's why the table name is Terraform lock. And make sure if you are using this, it will be pay per request. That means how many times you execute it. So there will be a pay, that is, AWS will bill you. And here I'm saying hash key should be the lock ID. It will be a generated lock ID. Okay. So this is the DynamoDB logic resource code. And here you can have type as S or Y or other things, where the type is string or Boolean or anything. What should be the lock ID type? Perfect. So now when you mention this particular thing, that is, if you say the resource DynamoDB, what will happen is the lock, Abhishek holds the lock on this particular Terraform project because Abhishek is executing it. Once the Abhishek's execution is done, Abhishek code change is done, and Abhishek has applied the configuration, the lock will be removed, and now other person who will execute it, they will hold the lock. So what Terraform will do, whenever it is running the Terraform apply command, what it will try to do is, firstly, it will check if anyone holds the lock. If someone holds the lock, it will tell that please wait, someone is holding the lock. And once they freeze once they unfreeze, or once the execution is done, the lock will be released and then I can take the lock. Okay. So for that reason, we will use this particular thing called DynamoDB. And this is the logic. Now what I need to do is I can just go through the go to the backend configuration. And in the backend configuration, I will just provide the details of my lock. That is, where should be the lock provided. So here I can say DynamoDB table followed by the name of the table. What is the name of the table? Terraform lock. So just update that. And now once you execute this one, what will happen? Terraform, let's say init, backend configuration changed. What has happened? A change in the backend configuration. Did I miss something here? Okay, sorry, because I'm updating directly here. Initially, what I should have done is I should have first created S3 bucket. I should have first created DynamoDB. And after that, I should have updated this backend configuration. But what I'm doing is I am doing it in the other way around. That's why it is giving me an error saying that the backend configuration is updated. So in your case, what you will do is before creating the backend.tf, firstly, just execute this particular project. Okay. Do not execute along with backend.tf. What you will do is I will provide this main.tf file. Just copy paste this main.tf file, or just delete the backend.tf file, or comment out this particular part in the backend.tf and execute the project. Then your S3 bucket along with the instances and DynamoDB will be created. After that, just uncomment the backend configuration and execute that particular thing. So you will implement backend mechanism with DynamoDB locking as well. Perfect. So I hope the video is clear and you got all the information about Terraform state, remote backend and locking mechanism. Try to execute this project. I'll provide the entire code. This is a very simple code. You must have seen that I wrote it with the help of documentation as well as the Visual Studio extension. So this is not a difficult part. But if you execute it, you might run into some questions. By watching the theory, you might run into some questions. If you have anything, ask me in the comment section or use ChatGPT or some other resources. But definitely provide the feedback to me in the comment section. Thank you so much for watching today's video. Take care, everyone. Bye-bye. Hello, everyone. My name is Abhishek and welcome back to my channel. Today is day 5 of Terraform Zero to Hero series. And in this video, we will deep dive into a concept called Terraform provisioners. There is a twist in today's video. I will start with the practical implementation first, and then I will move towards the theory part. Why? Because in today's video, we will see a day-to-day task of DevOps engineer and how DevOps engineer use provisioner with Terraform. So please watch it till the end so that you will learn a lot about Terraform provisioners and you will also understand scenario-based questions related to Terraform provisioners. Now, before I get started, let's quickly recap what we have learned on day 4. So on day 4, we learned about very important concept of Terraform, the heart and memory of Terraform, that is Terraform state management. So what did we learn there? We learned what exactly is a state file. We saw how to integrate and how to put the state file in a version control system. If you put that, what will be the challenges? Of course, I have explained why it is a bad practice to put the state file in a version control system and how to overcome that using the concept called Terraform backends. There, we learned what exactly is a remote backend and how to use S3 bucket as a remote backend in Terraform. Finally, we covered the concept called locking and locking mechanism of the state file using DynamoDB. So please watch that video. It's a very important concept if you haven't watched. Okay, so let's start with the task, right? So let me clean up my screen. Now I'll explain what exactly is the task that we are going to learn. So let's say there is a development team called XYZ, and this development team has a requirement that whenever they modify their application, So let's say they have an application called app.py. So this is a Python Flask application, for example. So every time they make changes to the app.py file, they want the DevOps team to create a Terraform project. Okay. And what is the scope of this Terraform project? So to test their changes, they want us to create a VPC. Within the VPC, they want us to create a public subnet. So how do you create a public subnet? Basically, you need to create a subnet first. And for that subnet, you have to create route table. And the destination for that route table has to be internet gateway. And you need to associate this route table to the subnet so that it becomes a public subnet. We have learned this during our AWS course. And then you need to create a EC2 instance, deploy this particular application. So they will share us the app.py file. So you need to deploy this app.py file onto the EC2 instance and expose this to the external world so that they shared you the app.py file. You create all of these things and you provide them a URL. Let's say the URL is 3.4.6.7:80. They will just hit this particular thing and they want to verify if their application is working fine or not. So for that, you need to deploy your application on the EC2 instance and you need to configure the security group accordingly, because you need to open the port. If the application is running on port 80, you need to open that port so that they can access their application. So if they do this particular thing manually, it will take a lot of time for them, right? They have to create VPC, they have to create all this configuration, they have to make sure that the security group is working fine, and finally they will be able to do it. So let's say if this is taking 1 hour of time and this is just for one developer. So how much time you will save as a DevOps engineer? By creating this particular project, you will save a lot of hours of time, considering there will be multiple developers working on that particular project. And then there can be multiple projects, right? So this is a quite common task of DevOps engineer. Now, there are two parts to it. One, the first part is you will set up this entire Terraform project. And the second part is you will integrate this with the CI/CD approach. That means the development team will not share the app.py file with you. I mean, they will not share it in an email or they will not share it anywhere. What they will do is they will update this app.py file in a GitHub repository. And what you can do is you can configure Jenkins, which will pull, or you can configure GitHub Actions. Whenever there is a change, it will pull the latest changes of that particular GitHub repository and it will run the Terraform. So first, I will not explain you the CI/CD and all that part because it's very, very simple. If you have followed my DevOps course or anything, you will learn, you must have known, you might know at this point of time how to set up this thing, because it's a very simple thing. But the part one is very, very important of how to write this entire project and how to deploy the application onto the EC2 instance, right? So you will create VPC, you will create public subnet, you will create the route table, you will create the EC2 instance, but how to deploy this application, right? I don't want to use Terraform user data, right? Why I don't want to use Terraform user data, EC2 instance user data? Because in user data, you can write a script, but let's say you want to deploy a complex project. Let's say you have 100 files, or let's say you have a project that is not suitable for user data. User data is fine when you want to run a small script or something. But when you want to execute a complex project, there we will use a concept called provisioners. So I'll explain the theory part. But before that, let me run this particular thing and show you. And all of you can, by the time I upload this video, you will see a folder called day5. And in that particular folder, you will see the Terraform project and you will see the application. So don't worry about that. But what you need to do is you need to practice this at your end. You can put this thing in your resume because this is a quite common DevOps task where DevOps engineer work on such activities on a day-to-day basis. So firstly, I've opened the GitHub code spaces. I have told you previously also that I'm going to use code spaces for this entire thing, because for people who don't have laptops, or people who um, cannot install Terraform on their personal machines for some reason because of the resources or something, they can use this way, so that code spaces will help them to set up Terraform and run the Terraform projects. So I have created a folder called day5 in my code spaces, and this is a very simple Python application that I want to demonstrate. You can show your creativity. I just wrote this particular written statement which says hello Terraform. Let's say previously it used to say hello Abhishek, and now DevOps engineers, the development team has changed this to hello Terraform, and now they want to verify this particular changes. Okay, so they shared this app.py file with you, and I wrote the Terraform project with very, very detailed steps. Anybody who follow this particular file, they will understand everything, but you need to know the steps first, right? Whatever the steps that I've explained, you need to know all of these first before you write the Terraform project. If you don't know these steps, how will you write the Terraform project, right? Many people are scared about Terraform because they don't know the concept of how to create resources manually. If you know how to create resources manually, writing those things in Terraform is a cakewalk, right? So that's why you need to learn the cloud provider first. You need to learn how to create resources manually in the cloud provider. Only then you will be able to implement things very easily using Terraform. So see exactly what I've explained you. Firstly, I wrote what is the provider. I said provider is AWS, region is US East 1. You can change it. Then I want to create the VPC. So for the VPC, firstly, I have to define the CIDR block, right? When you create AWS VPC through the UI, what is the first thing that you have to do? What is your CIDR block? That means what is your IP address range? So I said 10.0.0.0-16, sorry, /16. Then what I'm doing is I am choosing my AWS key pair, right? This is a very simple thing. What you need to do is on your workstation, wherever you are using it, just run this particular command called ssh keygen -trsa. So this will create, ssh keygen, there is no hyphen there, -trsa, and this will create a public private key for you in your local, and I am just uploading that public key so that I will use that to my EC2 instance, right? So I want to do this entire project from scratch. That's why I'm doing it. Okay, so I'm creating my key pair. Then what I'm doing here is this particular block here will create a VPC, right? And the CIDR block comes from here. So that's why I have defined it. If you don't want to variabilize it, you can just provide the CIDR block here as well. But it's a good practice to variabilize it. So I've provided the resource here, right? And if you don't even want to mention the default, like I explained in day 3 or day 2, what you can do is you can provide the value for the CIDR from the terraform.tf vars. Okay, then I'm creating the subnet. See, I'm following the same order. Firstly, I've created the VPC. Now I'm creating the subnet. Okay, so what I'm doing here for the subnet, I said the subnet has to be in this particular VPC, AWS VPC .myvpc.id. So Terraform will create this particular block. It will go and try to create AWS subnet, and it will understand that it has to put the subnet in this particular VPC. And there is no rocket science here. Entire thing is available in the Terraform documentation. I'll show you how to copy these blocks. Don't worry. But let me explain the project first. So VPC is provided, CIDR block. Now this CIDR block is for the subnet, right? This CIDR block is for the entire VPC, and this particular CIDR block is for the subnet. Then availability zone you can provide. Do you want any instance created in this subnet should have the, do you want to have the public IP or not? Yes, I want the public IP. Now This subnet, if you just create it, like I told you, this will not be a public subnet. What you need to do, you need to create a route table, you need to create internet gateway, and for the route table, you have to attach this particular internet gateway as your destination. So that's what I'm doing here. And then you will associate the route table with the subnet. See, I'm not doing anything different from what I've explained here. I'm doing exact same steps. For me, writing this particular main.tf just took 10 minutes. And this is a cakewalk for me because I know how to create this manually. If you don't know how to create this manually, only then you are scared about it. Many people are worried about how should I create Terraform, EKS using Terraform, how should I create a huge VPC setup using Terraform. Just sit down, write the steps. How do you do that manually on the AWS console? If you know that, then you can simply write it using Terraform. We will do that as well. I'll show you how to create EKS project using Terraform. But like I told you, if you know it how to create manually, then that's not a big deal. Finally, I told you that I want to expose this particular instance application on the instance public IP address. So that's why I'm providing a AWS security group. I'm creating it, and in the ingress configuration, that means in the inbound configuration. So in Terraform, inbound configuration is represented using ingress. Outbound configuration is represented using egress. Okay. So in ingress, I'm saying open the port 80 as well as 22. 22 is for SSH. Let's say something went wrong. You can SSH to the instance and you can see. It can go wrong in the particular demo as well. I don't know. If it goes wrong, I'll log into the instance and I'll fix it. Then I'm exposing the port number 80. Egress configuration, if the instance want to access anything from the outside world, you can just provide the egress configuration. Right? Finally, this is the EC2 instance configuration. So this is a key one, right? What I'm doing in the EC2 instance configuration, I'm providing what should be my AMI, what should be my instance type, what is the key value pair, right? Key value pair I've created here. I'm not using any existing key value pair. So what I'm doing, AWS underscore key pair dot example dot key name. So that is exactly what I've mentioned here. AWS key pair dot example dot key name. Security groups, definitely you have to provide. Subnet, you have to provide, right? We are following the same steps here. And then comes the part that we want to learn today. So if you just provide all of these details, what would happen? All these steps will be created. VPC is created, subnet is created, route net, EC2 instance, security group, and you will also get a public IP address for your instance. But one additional thing that we wanted to do was to deploy the application. Now, how will you deploy the application? Because Terraform is meant to create infrastructure, right? Using Terraform, we will create the infrastructure. But there is a concept in Terraform which is called as provisioners. We will learn the theory part in next 5 minutes. But this provisioners, for now, just understand that using provisioners, you can deploy this application on the EC2 instance. Provisioners is a very, very powerful concept. There will be a lot of scenario-based questions. So we will see the implementation. And when I explain the theory part, I'll explain the use cases of provisioners and what are the different types of provisioners, right? So using the provisioner, what I'm doing is I am just deploying the application. So if you see here, if I scroll down, so instance is created till here. Then what I'm doing is I am telling Terraform how to connect to the particular instance that it has created. So for that, I'm saying use the protocol called SSH. The username, because I'm using a Ubuntu instance, the username is Ubuntu, and I'm providing the private key information, right? Because public key is uploaded to the EC2 instance or is uploaded to the key pair resource of AWS. But to connect to it, you need a private key. That's what we do, right? SSH -i private key. So same steps you have to provide to Terraform as well. And what is the host details? That is what is the public IP. So because you are already in this particular resource block, you can simply say self.public IP. So if you are outside this resource block, to connect to that particular instance public IP, or to get the instance public IP, you have to say resource dot resource name dot public IP. But if you are already in that particular resource, whether you want to access AMI, whether you want to access instance type, whatever, if you are inside that particular resource block, you can use the self keyword and say self.ami or self.public IP. So that's what I'm doing here. Host is self.public IP, right? So I've connected to the EC2 instance using Terraform. Now I will use provisioner. To use provisioner, you should firstly definitely connect to the instance. Now using provisioner, what I'm doing is, don't worry about this particular thing. What is a file provisioner? What is remote exec? Because I want to do the demonstration first. I'm just showing you. So there is a particular provisioner called file provisioner, using which I'm copying this app.py onto the instance. So source I've provided as app.py, and destination I'm copying it one particular location. And then I'm using another provisioner called remote exec, and I'm executing all of these commands on that particular EC2 instance. What I'm doing, I'm installing the Ubuntu related packages for Python, and I'm executing the Python application from the Terraform itself, right? Now let us try to see if this will work or not. If there will be any issues, I'm ready to fix it. Firstly, let me do the Terraform destroy. If there is already something, okay, it said Terraform destroy is successful. There is nothing. Now I'll do Terraform init. Because I'm not using any remote backend, or I'm not using any special configuration for the provider, the initialization took very little time. Now, if I do Terraform plan, it will show, oh, sorry, I need to switch to the directory first, right? So I switch to day 5. Now, if you want, you can do Terraform init one more time, initializing the backend. Right, there is no backend provider, so it will take very little time. Now let me run Terraform plan and show you. So the Terraform plan will clearly show you that it is going to create all of these resources. What is that? One is it will create VPC. 2, it will create the key value pair. 3, it will create subnet. 4, it will create route table. 5, it will create internet gateway. 6, it will associate the internet gateway with your subnet. 7, it will create EC2 instance. 8, it will associate the security group with the EC2 instance. That is in the EC2 instance configuration only. So overall, there has to be 8 resources that Terraform has to create. See, what does it say? No changes, your infrastructure. Okay, let me execute Terraform destroy. I think I have this particular configuration already on my AWS when I was doing the demonstration. Okay, we will delete everything and then we will re-execute the Terraform plan. Always do the Terraform destroy, right? So it says 8 resources are destroyed. The reason why you have to execute Terraform destroy is sometimes you might use a lot of Terraform projects. Sometimes you might download mine, you might download someone else's, and you start working, learning Terraform. And if you forget that, manually deleting those things will be very complicated. That is one. And 2, if you forget, you will be billed by AWS, right? When I was doing the giveaway, I saw many people saying that, oh, we lost around $50, we lost around $60. Someone said that the AWS billing went up to 20,000 INR as well. So why does that happen? You create some NAT gateways, you create some public IP addresses, elastic IPs, load balancers, and you just forget, right? So don't do that. Always good practice is to run Terraform destroy. If you want the Terraform to create project one more time, just run Terraform apply, right? So let's do Terraform plan, and it has to create the 8 resources that we talked about. So this will take time. So it said 8 resources to add. Perfect. Now let's run Terraform apply. Perfect. Let's see how does this go. So it says 8 resources to add. What are those 8 resources? Exactly what we discussed. Okay, I'm not repeating it one more time. I don't want you people to get bored as well. Okay, so now you will see that it will not just create the resources, but it will also run the scripts, right? This is a new part what we are learning today. Previously, we learned how to provision infrastructure using Terraform, but we never learned how to create or how to execute scripts on the created resources using Terraform. And that's where your provisioners will come into handy. And they are very, very powerful, like you have seen in today's video. That will eliminate any manual intervention. You don't need any complicated user data scripts, or you don't need anyone's manual intervention. They don't have to log into the instance at all. And your application is available. So you are reducing developers 1 hour time, not just by implementing CI/CD or not just by provisioning infrastructure using Terraform, but you are automating the end-to-end process. This is called zero touch automation, because they are not doing anything. They are just creating a Jira request, or they are just executing the Terraform project that you shared with them. If it is integrated with CI/CD, they'll go to Jenkins and run it. If not, they will just go to their machine, download Terraform and execute it, right? And they will get a public IP address. All that they need to do is just access that public IP address and test their application. So see how DevOps engineers are extremely handy for the developers. That's where the developer operation comes into picture. So now, while I was explaining you, what happened is that the instance got created and Terraform is installing all of these packages, right? So Terraform connected to the EC2 instance, it copied the file, and now it is installing whatever we have mentioned, right? So I said apt update, it is currently running the apt update. Then it will install Python pip. Then it will switch the directory because I have copied the file to this particular location. Then it will install Flask and it will run the Flask application. Okay, so let's see what has happened. It said the execution is totally successful. It has installed all of these things. Perfect. Now I hope this is all good. Let us go to the EC2 instance first. So for that, what I need to do is just go to my EC2 tab, right? And let us see if it has created an EC2 instance. Perfect. There is only one EC2 instance that is running and it is still initializing. That means this is the EC2 instance that we just created. You can also provide the name to the EC2 instance. Simply provide a tag, right? Now let us log into this particular EC2 instance, right? So how do I do that? Just copy this one and you can take a new tab here. Click on this plus button and it will give you a new tab, so that your Terraform things is in one particular tab and your this thing is in a different tab. Now what I'm going to do is I will log in SSH -I, because I've used public IP, key value pair on my particular machine. So I can just say SSH ID RSA Ubuntu @instance. So it will allow me to log in, and let us see if Flask is installed, Python is installed, and everything is working fine, right? So sorry, okay, ls. So app.py file is copied, right? What is the location? Home Ubuntu app.py. That is exactly what we mentioned, right? We asked the file provisioner to copy the file. Where exactly is it, right? To copy the file to this particular destination. And then I've asked the remote exec to run all of these commands. So let us see if Python is installed first. Perfect. There is Python here. I think Python comes by default, but we have installed pip, right? So let us see if pip is there or not. So how to do that? If you just execute this particular application, right? Let us see first if the application is running or not, right? That would be easy thing. So I can do ps -ef. Let me use sudo ps -ef. I'm just seeing the running processes. ps -ef grep. Let me see if there is any Python process that is running. So it said that there is no Python process running. Okay, why? Strange. Okay, let us see if we can execute that. Sudo python 3 app.py. Okay, it is executing it. Now let us open this particular address and see what is happening. So it should not be HTTPS. Make sure you remove that. Perfect. It said hello Terraform. Okay, there is no problem. For some reason, this particular command did not get execute. I can check what is happening. I think it is running as a background process, and probably because we are running it from here, that is not getting reflected. We can modify this particular thing. But for now, what I've done is I logged into this particular instance and I've executed the app.py command. Okay, this is not a big deal. You can simply log in. I'll troubleshoot and see what is happening or what is going wrong. But what I've done here is I've just logged into the instance and I've run this particular last command, that is python 3 app.py. Now see what has happened. Developer has shared this app.py file with you and this entire project is executed, right? They got the EC2 instance, they got the VPC configuration. They can simply verify that if their change is perfect or not. And if their change is perfect, they can say that the verification is done. Thank you so much, DevOps team. Perfect. So this is the demonstration. Now let's learn about the theory part, right? So what exactly we did. So I hope you all know from here to here what exactly we have done. I need to focus on the provisioners part, right? So what exactly is a provisioner? So if you watch the demo carefully, what exactly has happened is that we just did not create the infrastructure, but we use this concept of provisioner to execute plus implement some actions during the creation, right? So what did I do? At the time of creation of EC2 instance, I have copied the file plus I have executed some commands, right? So provisioners are resources in Terraform, or provisioner is a concept in Terraform that will let you to copy some particular things or execute some particular actions at the time of creation. Not only at the time of creation, but you can also use provisioner at the time of destruction. That means during the deletion of resources also, you can use this concept called provisioners. By default, if you execute, it will run like, let's say you have created a provisioner concept in your Terraform project. By default, if you're not providing anything, they will run during the creation. But if you want to run them during the destruction, you have to tell inside the provider block that please run this particular activities during destruction. Now let's try to understand why will DevOps engineers use this provisioner concept during creation or destruction, and what are the different types of provisioners. So as a DevOps engineers, right, when you are using Terraform, you will see some challenges with Terraform. That means even Terraform is very, very powerful, but still it lacks some basic things. Example is what we have seen in the particular task, right? So using Terraform, you have created EC2 with all the required configuration, VPC and all, but you were not able to install the Python if you don't use provisioners. So what will happen? Let's say if Terraform did not have a concept called provisioner, the problem would be you need to use any other tools like Ansible, right? Or you need to use shell script to connect to the instances, right? If there are 1,000 instances, so you need to use Ansible to connect to it. For this very simple task, to just run the Python application, you have to write a Ansible playbook, or you have to write a shell with connecting to the instances, and you have to execute all of these things. So to solve this problem, Terraform said, okay, don't worry, I will provide you two things. One is called as remote exec provisioner, and the other is called as local exec provisioner. So what does remote exec provisioner do is, if you are using remote exec provisioner, at the time of creating EC2 instance itself, you can connect to that particular instance or you can connect to that particular resource. And what you will do is you will execute any kind of commands. It can be installing Python, it can be installing Node.js, it can be installing Java, right? Anything. So any shell commands that you want, it can be one shell command, it can be 100 shell commands, it can be 1000 shell commands. It does not matter. Using remote exec, you will connect to the instance at the time of creation of the instance, and you can run all of these things. Then there is something called as local exec. So local exec is a fairly simple thing. So let's say you want to print anything on the console. Okay, while running the Terraform project, you see that Terraform prints a lot of things, right? So here Terraform prints that okay, your this particular resource is created, right? Your EC2 instance is created. But during the creation itself, if you want to say that just print a echo statement for your customer or your user saying that okay, Terraform has done 1 out of 8 tasks, Terraform has done 2 out of 8 tasks, or you can just say create a file. Okay, you can create a file for your entire Terraform execution. Now by default, what Terraform does, whenever you run Terraform apply, whenever you run Terraform apply, Terraform will print everything on the console. Okay, all the resources that it is creating, everything is in the console. Now let's say I want to go back and see the Terraform output. I can't see because see, I'm scrolling down, but I'm not able to see because your terminal has a specific number of lines that it can show. But what if your Terraform project has some 10,000 lines of output? So instead of printing everything on the console, along with printing, what you can do is you can use the local exec. Okay, and you can ask Terraform to copy all the output to a particular file. Okay, it can be anything. Like you can show the progress of your execution in this particular file. You can say EC2 instance is now created, subnet is now created, etc., etc. Okay, you can print all of those things. So this is about local exec. I've explained what exactly is a remote underscore exec, right? Now, along with this, there is one more very important thing called as file provisioner. File provisioner is basically, the name itself says that it is used to copy the files. Okay, let's say you have created a RDS instance or you have created an EC2 instance, and in that particular EC2 instance, you want to copy some 10 files. It can be source code, it can be some configuration files, it can be some JSON files, YAML files, whatever it is. Okay, so using the file provisioner, you can copy the files. That's what we did, right? So that's why I did today's demo with both the file provisioner as well as remote exec. What I've done is I've used the file provisioner to copy the app.py onto the instance, and then I've used the remote exec to copy the file, to execute the file that is copied using the file provisioner, right? So you can use local exec as well in this particular demo and just print that hello, the Terraform execution is going on right now, the instance is created, right? Or anything that you would like to. You can maintain a single file, and let's say you have 10 resources. So here you have 1 resource, here you have 2 resource, 3 resource. In all of these things, what you can do, okay, of course you cannot do it here because these are security groups and other things. But for some resources, example here, when you are using the EC2 instance, here what you can do is you can write the local exec and you can print anything on this particular terminal or in a particular file, right? So this is about today's video. I will cover local exec in some other demonstration because I don't want to complicate this particular thing. Probably when we do the EKS cluster creation or when we do the complicated project using Terraform, there I will show along with the local exec, I will also show the remote exec because there it is most needed as well. When we are creating such complicated projects, provisioners will come a lot of handy. The reason why we are learning these things like day 1, day 2, day 3, 4, and 5, why we are learning things with scenarios, why we are learning things with theory and practical, because they will help you in creating big projects. These are day-to-day tasks of DevOps engineers. But why you are scared when you want to create EKS cluster? Because some people don't understand the concepts that we are learning in day 1 to day 7. And if you want to directly create EKS cluster using Terraform. EKS cluster will be some 1,000 lines of Terraform script. For example, they will be scared. Okay, it is very complicated. Terraform is very complex. But if you don't have the basic knowledge, yes, Terraform is complex. But if you have the basic knowledge, I just wrote this 100 lines in just 10 minutes. Of course, I'm using this IDE, I'm using the plugins. I have taken help of documentation, but it is very, very simple because I know the concept. Whenever I'm getting some doubt, let's say I don't know how to, I don't remember the syntax of remote exec. What I'll do, similar to you people, I'll just go to Terraform documentation and I'll search for remote exec. Okay, so Terraform will give you the entire thing. See, it gave me the syntax that I'm using. What did it say? Resource, AWS instance, web. It provided me the connection block. It provided me the remote exec block and this particular thing. I just removed this particular lines and provided my things. See, this configuration is exactly same. In my case, I just said connection. I use the remote exec provisioner. I use the inline, and in inline, instead of Puppet, I use the Python script, right? Isn't it amazing? Perfect. Now there is one simple task to you people. I want to see if how many people are following it, right? How many people are actually understanding what we are doing with Terraform. So try to execute this project and let me know in the comment section if you are able to do it or not. And finally, try to debug what exactly went wrong here, right? It's a very simple thing. If you try to understand what exactly is happening, you will understand where and what exactly did we miss. But it's okay. When you're trying to do the initial demonstration, follow the same video. And if this particular thing is missing in your case as well, just try to log into the instance and execute the command. And in the comment section, let me know what went wrong. What did I miss in this particular action and why the Python did not run, or why the Python application did not run directly using Terraform. So all this 101 lines got executed, but what happened to this particular line? Okay, anyways, I hope you enjoyed today's video and I hope this video is very, very helpful to you people. Let me know in the comment section what is the feedback and how did you find this day-to-day task of DevOps engineer, and are you confident that you will do this particular task? Thank you so much for watching the video again. Take care, everyone. Bye-bye. Hello, everyone. My name is Abhishek and welcome back to my channel. Today is day 6 of Terraform Zero to Hero series. And in this video, we will deep dive into the concept called Terraform Workspaces. Before going to the video, if my voice is not clear or if I'm not sounding well, please bear with me for today. I'm not keeping up that well, but I will try my level best to pitch the audio as clear as possible. Let's go to the GitHub page and see what we will learn as part of day 6. So as part of day 6, firstly, we will start with understanding what exactly is Terraform Workspaces and why and what problem is Terraform Workspaces is solving. Then we will learn how to create the Terraform Workspaces, what commands to use, and how to switch between the workspaces. Finally, we will move towards doing a practical demonstration where we will see how to set up Terraform Workspaces for different environments in your organization. That means instead of rewriting the Terraform project, once for the dev environment, once for the stage, and once for the production, we will write one Terraform project, we will use workspaces, and we will use that same project for n number of environments. So we will try this practical. I am also not prepared for the practical, so there can be some mistakes, but we will try to debug it live. So it's going to be very raw and it's going to be complete live. So let's get started. Firstly, we will understand what exactly the Terraform Workspaces is. So let me explain this with a real life use case. So let's say there is a developer team called XYZ, and they have a very simple requirement that they want to set up EC2 instance plus S3 bucket on the AWS environment. And they might want to do it each and every day. So instead of creating manually, or probably they don't have permissions. So what they did is they created a Jira ticket on the DevOps engineering team dashboard. And as a DevOps engineer, you happen to pick this request. Okay, this particular request is assigned to you during the planning, and you said that you will work on this. Because you have good knowledge on Terraform, what you did is you looked into the request very carefully, and you said that both EC2 and S3 bucket are quite commonly used resources. What does that mean? That means in future there can be a team called ABC or EFG, and these teams again might come to the DevOps team, or they might again end up creating Jira tickets to the DevOps team asking for the same resources. So because you are master in Terraform, what you did is, instead of writing the Terraform project that is just used by the XYZ team, you wrote a Terraform module. And the advantage would be, because you wrote this in the modular approach, this is reusable. That means you are not just solving the problem for XYZ team, but you are also solving the problem, the future problem of ABC, EFG, blah, blah, blah. There can be n number of teams, and you are solving all of their problem. And what you will do is, along with the module file, you will also create one more file called, let's say, readme.md. And within this file, you will provide instructions on how to use the module. Or if someone is not at all familiar with Terraform, so you will help them in writing the main.tf file. So for this particular team, XYZ team, let's say you wrote the main.tf file, and in that you have provided instructions on how to consume this particular module. If it requires for you to create variables.tf or tfvars, you will do all that configuration. And again, if any of these people are coming to you, you will just provide them the readme.md file, or you will provide this particular project as reference for them. And if they have permissions, they will do it. So this is one of the major problem that you have solved using the modular approach. So what problem you solved? Instead of rewriting the Terraform project multiple times, what you did is you wrote a module that is reusable. But what if I tell you that there is still one problem for XYZ team? And what is their problem? Let me clear the screen. So their problem is that they will come to you and say that XYZ team will approach you one more time, and they'll tell that, Abhishek, what you have done is very good, and we have tested this in the dev environment. Okay, so in the dev environment, what they did is they wrote the main.tf file, or you helped them in writing the main.tf file, and you wrote the entire configuration. And to variabilize this, because the module is complete variabilized, so you have also set up terraform.tfvars. Okay, and in the terraform.tfvars file, you said that the instance should be of type t2.micro. So you have not hard coded it, but you are providing this in the terraform.tfvars file. And they said, Abhishek, we have tested this, both the EC2 instance and S3 bucket are created, and we are super happy that you have solved one of our problem. But we also have a staging environment, we have a production environment, and some teams, they might have pre-production, developer, anything, right? So there can be 3 environments, 5 environments, or 10 environments. So now they will ask you, but Abhishek, if I have to create the same things, but my EC2 instance for staging, let's say, is of type t2.medium, and for production it is of t2.xlarge. So they will ask you, Abhishek, do I need to create the main.tf file and this particular terraform.tfvars file one more time? And for production, do I need to create one more time? For pre-prod, do I need to create one more time? So you will start thinking how to solve this particular problem, right? Because they are not different projects, and they don't want to rewrite this multiple times. If they have 100 environments, it is not a good practice that they write all of these files 100 times. So you might be thinking, but Abhishek, why should I do that? I can simply write one main.tf file. Okay, and what I can do is, for developer environment, I can ask this particular team to write dev.tfvars. Okay, for staging, I can tell them to create stage.tfvars file, right? And for production, I can ask them to create prod.tfvars file. Okay, so you might be thinking this, Abhishek, will this not solve my problem? No, because You might do this, but there is one particular thing in Terraform called as Statefile. And you all know, what does Statefile do? Statefile will record the information. Let's say when you executed for this particular thing. Okay. So let's say you executed the main.tf and dev.tf for creating EC2 instance on the dev environment. So Statefile will record this particular thing, right? And then when you execute for the stage environment, so there will not be another stage file by default, right? So this particular state file will be overridden, or what will happen? The state file will be confused and it will say, okay, probably this particular person is trying to modify the dev.tf vars, because it does not know that you have multiple environments, or it does not understand. What it does is it will learn that you are consuming the module, and in the module you are using a EC2 instance. So what it will try to do, it will try to delete, or it will try to modify the EC2 instance that you have created for the dev environment. And when you execute for the prod, again it will do the same thing. But what is the expected behavior? They need different infrastructure for dev, they need different infrastructure for stage, and they need different infrastructure for production. And they don't want to rewrite all of these files again and again. So they don't want to create a folder for dev and write main.tf and all the files. They don't want to create another folder for stage, and they don't want to create another folder for production. So to solve this particular problem, what Terraform said is, okay guys, don't worry, we have something called Workspaces. And what exactly this will do is, Workspaces will maintain, or it will solve the problem of single state file, right? If there is one single state file that is causing the problem. So what Workspaces will do, it will create state file per environment. That means there will be a folder that is created called Terraform state.d or something like that. And inside that, there will be a folder for dev, there will be a folder for stage, and there will be a folder for prod, depending upon how many environments do you create, or how many workspaces do you create. If you create 100 workspaces within the same folder, within the same project, you will have folders for each environment, and inside the folder you will have a state file. So that when you are in the dev workspace, this particular state file is updated. When you are in the staging workspace, this particular state file is updated. When you are in production, this particular state file is updated. So the state files are not overlapping. So within one Terraform project, so you don't have to write Terraform project again and again for each environment. You will write Terraform project only once. And because you are using environments, and because you are using workspaces per environment, state files are created per each environment, and you have unique state files. So there is no problem of conflicting infrastructure. When you create infrastructure for dev, this state file is updated, and EC2 instance plus S3 bucket according to the configuration is created in the dev environment. So it can be anything. This can be a different region, or this can be the same region. But when you execute for staging, again a new EC2 instance plus S3 bucket is created, and this EC2 instance will be of T2 medium. And when you execute for prod, another EC2 instance plus S3 bucket will be created, and this will be of T2.xlarge. I'm repeating again, if you are not using the concept of workspaces, this particular EC2 instance firstly will be created for dev environment, and when you execute for staging, this particular EC2 instance or any resource, either it will be deleted or this resource will be updated. Because there is only one state file, it will not understand that, okay, you are creating for dev, you are creating for stage and prod. It will understand that, okay, you have created EC2 instance, now you have changed the configuration, so let me update or delete and recreate this particular resource. Similarly, when you do the for prod, either it will update or delete and recreate the resources. Okay, if you are using workspaces, what exactly is happening? And state file is created per environment, so the infrastructure is created per environment, and they are not conflicting with each other. Now let's see this in real time so that you will understand this in a much better way. So what I'll do first is I will restart my code space. You all know, for this particular Terraform series, I am completely using the GitHub code spaces itself. Not that I don't have a laptop with proper resources, but Just that if anyone is watching these videos and if they don't have a proper laptop, or if they cannot configure everything in their personal laptop, they can watch these videos and they can start using Codespaces, which is free for 60 hours per month. So it will take a couple of minutes. Let's wait. Perfect. I hope it is set up now. Great. So because we are on day 6, what I'll do is I'll create a folder called day 6. So I'm doing right from the basics. So please watch it. And if there are any errors, I'll fix it live. Perfect. So let's take the task. We will simplify it. Let's say we only want to create EC2 instance. Okay. So what I'll do, like I explained you, XYZ team came up with a request that Abhishek, I want to create EC2 instance. Okay. So what you will do is you will start writing the modular approach. So I'll go here, I'll create a folder. So you don't have to use the same repository. You can create your own repository. You can create one repository for day 1, day 2, day 3, as you like. I just want to keep it everything in the same repo. So inside the day 6, what I'll do, I'll create a folder called modules, and I'll create a folder called EC2 instance. Why I'm creating another folder for EC2 instance? Because in future, if I have to create module for S3 buckets or something, I can keep it under this module folder. Perfect. So now modules folder is created and EC2 instance is also created. Now let's write the code. So firstly, I'll start with writing the main.tf. And in the main.tf, you all know, if you're watching these things from day 1, so Codespaces comes up with Visual Studio Code, and I have very cool extensions that I've explained in day 1, which is HCL plugin, and I also have the Terraform related plugins. So if I just enter provider, you will see that the code is auto-populated. So you can watch day 1 and day 2 to understand how I have configured this. So the auto-completion feature is enabled. So provider, and I'll mention the region as, let's say, US East 1. So how do I do that? I just need to mention, sorry. So let's just say region is equals to US East 1. Perfect. And now I'll start writing the code. I'll say resource EC2 underscore, sorry, AWS underscore instance. See, everything is getting populated. And here I'll just mention, let's call it as example. And then what I'll try to do is I'll provide the instance configuration. So I'll say AMI, very basic configuration. Let's say we just have a AMI and we just have instance type. Perfect. And let's variabilize this. You can create a folder file called variable.tf, but for the purpose of demo, let's put it in the same file. I'll say variable, and let me call this as AMI itself. And I can mention some description, say that this is AMI for the instance, just for the good practice, so that you people will develop this habit. If not, I can simply ignore the description, but because I want you people to make this as a habit, I'm just writing it. This is the instance type, for example. So you can write it as elaborate as possible so that anyone will understand. Now what I'll do is I'll simply say var.ami, and here I'll just say var.instance type. Perfect. So this is the module that I've written, and this module has main.tf, and it also has the variables, and it has the EC2 instance configuration. And I've not hard coded any of these things, right? Everything is coming from the variables, and whoever wants to consume this module, they can create their own terraform.tf vars. So you wrote this module, and now there is a team called XYZ, let's say. So they can use this module, they can use it in anywhere. They can use it in a GitHub repository, in a different GitHub repository, or in the same one. It's up to the access that they have. But because we are doing the demonstration, let me create this in the same folder. So what they will do is they will write main.tf. So I'm not creating in the same folder, I'm creating at the root of the folder. Let me show you so that you people will understand. So if I cd to day 6 here, what I've done, so if I just execute the tree command, you will see this is the approach that I'm following. So this is the module, And here I'm creating the main.tf. Okay, and this particular main.tf is for the project team XYZ. You can create this particular main.tf in this folder. I mean, in the day6 folder, you can set up a new folder. You can set up a new GitHub repository. It can be anywhere as long as it has permissions to access this particular module folder. Perfect. So let's go back. And now what I'll do is I'll continue writing the main.tf. So here you need to provide the information one more time. You have to say provider AWS. You need to mention the region. If you want, you can also variabilize the region in the in the module main.tf. I have hard coded it, but if you want, you can also variabilize it. Now, what I'll do is I want to use the terraform.tf vars and I want to submit the values for this EC2 instance. So what I'll do for that, I have to again set up variable AMI. Here I'll mention what is that? Description. So I'll just leave the description empty. I don't want to write it one more time. I'll say instance type description. You can add the description. You might be wondering, but Abhishek, why I'm writing this entire thing one more time? So whenever you are writing the modular approach code, the only thing that you will write, as a team that is consuming the module, the only thing that you need to write is variable and how to take the module, that is how to consume the module. So here, instead of resource block, let's say that the resource block is very complicated. In this case, the resource block is very simple. That's why you are thinking that I am writing the same code again and again. But understand, if in one Terraform project, you are creating 100 resources. In such case, what will happen is there will be huge module, but this particular main.tf file will become very, very simple. So module, let's provide the name for the module. I'll say EC2 underscore instance. I can provide any name, right? EC2 underscore instance. And here I have to mention from where I'm sourcing the module. So I'll just say /module. And here the entire game is from wherever you are reading the module, you have to provide the path. And then AMI is equals to, why I'm providing the AMI? Because in the module, what are the things that are required for the particular resource? AMI is required and instance type is required. If the AMI is hard coded, then in the module, you don't have to write this particular thing. Because AMI is hard coded, you don't have to pass anything. If you want, you can pass, but by default, you don't have to pass anything, right? So AMI is equals to var.ami, and here I'll say instance type is equals to var.instance type. Perfect. So this module will be invoked if I have a file called terraform.tf vars. So let me create that. Terraform.tf vars. Till now, I haven't created anything for the workspaces. Okay, I'm just creating the module itself till now. And in the terraform.tf vars, I'll just say AMI is equals to some value and instance type is equals to, let's say, t2.micro. And let's take the AMI value as well. In the day file, I'll have some value. I can pick it. Do I have something? I'm just trying to copy. So there is nothing here. I can see for day 4. Yep. So there is a AMI here. Let's copy. Perfect. Oh, shit. Sorry. So this is just copy pasting. You can copy it from your AWS console as well. Great. So now I've written the AMI and I've also written the instance type. Now what will happen if I execute? So we are at the very plain use case. That is, let's say they just have one environment. So what they'll do is they will go to day 6, CD, day 6. And if this particular team has only one environment, they'll just come here and they'll just say Terraform init. So it is initializing, and see here, it is taking this particular module as well. It has taken the module. And now if you just say Terraform apply, for example. Okay, I'm not doing plan. I'm just directly doing apply. So if I execute the Terraform apply, now what will happen? Watch carefully. I'm providing yes, and it will create a EC2 instance for me. And that EC2 instance will be according to the variables that I have provided. And if I go to day 6 folder, there is also a state file that is created, right? See, state file is getting created. Even if I look here, you will notice that if I do the tree command one more time, a state file is getting created at the root of the folder. It is not created inside the module. It is created at the root level, right? Because I'm executing from here. So the state file is getting created. And in the state file, you will notice that a EC2 instance configuration will be updated once it is created. Let's go back. See, it is still creating the EC2 instance. Finally, the instance is created. Now, as I told you during the theory part, what if, what if they just don't want this configuration in one environment, but they want it in the dev, they want it in the stage, and they want it in the production. So you might say that, Abhishek, it is very simple, right? What I'll do is I'll just come here. Okay. And just like I created TF-vars, what I'll try to do is I'll create one more TF-vars, new file. I'll call it as stage.tf-vars. And inside that, what I'll do is I'll just copy the same things, but in the stage.tf-vars, I'll say instance type should be t2.medium. Okay. And now what would happen if I execute this particular Terraform using the TF-vars for the stage? Any guesses? Let's see what will happen. So right now, what is there in the state file? If I do Terraform show, instead of going to the AWS console, if I directly do Terraform show, you will see that there is one EC2 instance here. There is only one resource called AWS instance. Name is example. And this is the instance ID, which ends with 74E. And the configuration for the instance is t2.micro. Now the expectation is that if I execute this particular code, okay, it should keep the environment for the dev, and it should create a new EC2 instance with t2.medium configuration. But will that happen? Let's see. I'll do Terraform apply -var -file. Is it is equals to, let's see, -var file is equals to stage.tf-vars. Perfect. Now it is getting created, and let us see what is it saying. See, it is not adding any new instance. It is changing the existing instance. But this is not what I want. What I want is I want in the staging environment a new EC2 instance. So for that, this particular thing that we have done is not working. What is not working? I cannot simply go here and create one TF-vars per environment. If I just do TF-vars stage.tf-vars prod.tf-vars, what is happening? The existing infrastructure is getting updated, but it is not creating different infrastructure for dev, stage, and prod. To do that, what I need to do is I need to use this concept called Terraform environment. Sorry, Terraform workspaces. So let's see how to do that. What I need to do is let me clear up all of these things. Okay, I'll clear all of these files. And in the day 6 also, what I'll try to do is I will try to delete everything related to the configuration files. So delete permanently. Okay, let's do it from here itself. What I'll do is I'll just do ls and I will delete the file Terraform state. I'll delete stage.tf-vars. Now I just have terraform.tf-vars. I just have modules and I just have main.tf. Okay. Now what I am going to do is I'll go back, and here I will run this particular command called Terraform workspace new dev. So immediately as I do that, what you will notice is if I go to the tree view, you will notice that a new folder is created, which is called terraform.tfstate.d. And inside that there is a dev. And now let me execute terraform.workspace. Sorry, new stage. And similarly, let's do prod. And if I refresh this and run the tree one more time, see inside terraform.tfstate.d, there is dev, there is prod, there is stage, but inside this there is nothing because we haven't executed anything. Now, what I'll do is I'll switch to, I just created the workspace. Now, let us say I want to switch to the workspace called dev. That is, I want to go into the workspace called dev. So for that, Terraform workspace, I think set, what is the command? Let's see. Select, sorry. So I'm not that good at remembering the commands, and I don't even want to remember if there is clear instructions. So what I'll do, Terraform workspace, select, and followed by, let's say dev. So now what is happening is I switch to the workspace called dev. You can see it by using this command as well. Terraform workspace show. Even if you use this particular thing, it will clearly tell you in which workspace you are in. And here, what I'm going to do is I am going to execute this particular tfvars file. So what will happen if I run Terraform init? First, let's run the init because I've deleted everything, right? So I'll run Terraform init. After that, as I run Terraform apply, you will see an instance getting created, but along with that, there will be a state file that is created inside this particular folders, but not at the root of your project. Or the state file is created for each environment. Let's see that. So if I just execute tree, see inside the terraform.tfstate.d, there is a new file called terraform.tfstate for dev. And this state file will not impact your production as well as staging infrastructure. If you make any changes in the dev, as long as you are in the dev workspace, okay, this is very, very important for DevOps engineers because you cannot create or you cannot recreate the complex infrastructure each and every time for each and every development team for each and every environment. Your work will be superly impacted if you start doing it. So what you will do is efficiently you will use Terraform workspaces. So here, if we go back, the instance is created and instance is created just for the dev environment. So if I go to the EC2 dashboard, okay, so let me just stop sharing once so that I'll not share my credentials. So if I just open it, AWS console, and I need to log into the AWS. Sorry, I should have done it before, but perfect. Let's share the screen one more time. Awesome. I hope you are seeing the screen. And here you will notice that there is a EC2 instance that is just created, right? It is initializing and it is of type T2 micro. Now, what I'll do is I'll switch to the workspace called Terraform workspace select stage. And here I'll just go to the same TFRs file and I will change it to T2 medium. Or you can maintain different TFRs as well. It's up to you. I'm just showing as part of the demo. If you don't want to keep editing it multiple times, what you can do, you can create multiple TFRs and you can pass it to your Terraform apply command. So again, what I'll do is Terraform apply. And watch carefully. What does it say? It will not change the resource, but it is adding the resource. Previously, we saw it is changing the resource. Here it is adding it. So if I go back and if I show this particular thing to you, Terraform, what is this? Sorry, if I just do the tree view, see again inside the stage, a new folder is created, a new file is created called terraform.tfstate. And if we continue this output, let's say yes, you will notice that a new instance will be created, and this particular instance will be of type t2.medium. And if we switch the workspace to production, you will see the instance will be of type t2.prod. So once this is done, I'll show you one more important thing. That is, instead of modifying the state, instead of modifying the tf_var file again and again, what you can do as a DevOps engineer. There are two good practices, and I'm going to show you both of them. I'll tell you which is better as well. Let the instance get created. Let me show you on the console so that you will believe on the concept of Terraform workspaces. Just kidding. So 30 seconds elapsed. I think it will be done in next 5 seconds. Let's see. 5, 4, 3, 2, 1. Done. So if we refresh here, you will see a new instance called T2 medium. Awesome. So existing infrastructure is not getting changed. Now you might think that Abhishek, EC2 instance is a very simple thing, but understand in terms of huge configuration. What if there is a configuration of VPC plus S3 bucket EC2 instance, and inside that, let's say you have Fargate, you have NAT gateways, you have all the configuration. So what would happen? Because this is just an EC2 instance, you are finding it, okay, one instance for this, one instance for this, but replicating the entire configuration for different environments will be huge task if you are not using workspaces. Just you try to imagine what you are trying to do right now, and imagine at a scale, so you will understand how useful Terraform workspaces is. Sorry. Done. Now, what one thing I finally want to explain you is, here to show you this particular thing, what I've done is, when I'm doing it for dev, I modified this particular tf_vars file. When I'm doing it for stage, I modified it again. For prod, I'll modify it again. This is not a good practice, right? You want things to be automated. So there are multiple ways to do it. One is, for each environment, you can create one tf_vars. You can say dev.tf_vars, stage.tf_vars, prod.tf_vars, and instead of updating, when you run Terraform apply, what you can do, what you can do is, you can just say Terraform apply minus var file is equals to prod.tf_vars, dev.tf_vars, stage.tf_vars. So that's why you don't have to overwrite the existing tf_vars file. Or the other thing that you can do is, see here we are modifying the instance type, right? So what I'll do is, instead of modifying this, I can simply say, I'll remove this value from the tf_vars. I'll go to the main.tf, and here in the instance type here, watch carefully what I'm doing. Here in the instance type itself, I will just say description can be there. I will change this to type map of string. Why? Because here I want to say for dev description value type, I have provided map. Okay, now let's provide the default values. Inside the default block, I'll say if the workspace is dev, then choose t2.micro. See, my auto extensions, my auto writing, or what do you call it? Sorry, auto type is coming into picture, or it is coming very handy here. For stage, if the Terraform workspace is stage, let's use t2.medium. And finally, if it is of prod, let's say t2.x large. And when I am writing this particular module, inside the instance type, I will use a particular function called lookup. Okay, what this lookup will do is, just hover over it, you will find that it takes 3 different things as input. One is, you have to provide which value should it look up. Okay, so here you will say the value that it has to look up is instance type, and inside that you will say what is the key. That means from the instance type, should I choose dev, should I choose prod, should I choose stage? And if none of these things are there, what should be the default value? So what I'm going to do here first is, I'll say instance type, comma. What I'll try to do here is, I will provide which value to pick up. This plays major role. Here, Terraform provides a particular variable for you by default, which is called as terraform.workspace. And this value, whenever you are executing, let's say you are in the dev workspace, this value will be resolved to dev. If you are in staging, this value will be resolved to stage. Okay, I'll show you what will happen. Finally, you have to take any particular default thing as well. Let's say default is t2.micro. I'm just providing some basic thing. You can change this to anything, or you can just say error or something. Now, what would happen when you execute this particular code? Currently, I'm in the staging environment, right? So when you execute this particular code, this variable will be changed to, during the execution, it will be changed to stage. And this particular lookup function, it will go to instance type variable. Okay, it will understand this is a map. It will go to instance type and it will search for stage. And if stage is available in this default block, it will take t2.medium and it will create instance type, or this instance type variable will be assigned with value t2.medium. If nothing is available, let's say stage is not available, because you have provided default value as t2.micro, this will be picked up. Now let's see. So what I'll do, firstly, I'll do Terraform destroy, because I want to show you this is working fine, right? Oh, I changed this particular thing, right? Sorry. Oh, my bad. And here, let me change it to Terraform.workspace. Okay, now it should work. Let's do Terraform destroy. So it will go to the state file of staging environment. What did I miss here in the line number 23? Just give me a second. var.instance type, right? I think this should be good now. Like I told you, there can be errors, and let's try to debug in the live, because I'm not at all prepared for this demo. I was not feeling well. Perfect. See, it is working fine. I'm just looking at the errors and I'm debugging it. I'm not doing anything. And you have to be very, very careful when you are dealing with Terraform workspaces, because accidentally you cannot delete state file. Let's say you want to destroy staging environment, and unfortunately you are in the production and you have executed Terraform destroy, your production will be completely destroyed. Of course, it will clearly mention you that you are trying to destroy workspace stage, but if you ignore that particular message, gone. So because you are dealing with multiple environments, when you are dealing with Terraform workspaces, just be extra cautious. I know usually DevOps engineers would look at this particular message and they'll be careful when they enter the value. Yes, Terraform, that's the reason why it has provided this field as well, but just letting you know. So destroyed. Now what I'll try to do is I'll show you this particular syntax is working with two things. One is we'll firstly move to Terraform. Let's say Terraform workspace, select prod. Okay, and I have not provided any variable in the tf-vars called prod. For prod, I have not provided anything. So now let's see if this lookup function will work fine or not. Let's see. Terraform apply. And now what I want to happen is it should create a T2 large instance or T2x large instance. Automatically, this particular variable should be resolved to prod, and it should go here and it should fetch the prod value called t2.xlarge. I'll submit this entire code in the GitHub repository and you can reuse this particular code. Okay, but make sure you practice it as you are doing the video, because it will help you in learning things. And these are the basics of Terraform. These are very, very important, because when you develop complex projects, all these concepts will help you in writing efficient Terraform code. And during your interviews, these are the things that they'll ask. Nobody will ask you to write EKS cluster in an interview, because it will take 1 hour time. Nobody will ask you that. They'll ask you to write workspace. They'll ask you to write module. So you have to be prepared for it. Now let us see. If I go here, now I should see an instance called t2.xlarge. Perfect. I have t2.micro, I have t2.xlarge. Why t2.medium is not there? Because I have destroyed it using the Terraform destroy. If not, all the 3 instances will be available. So that's about the demo. I hope you liked it, and I want everyone to practice it, because this is very, very important. And You might run into some errors, you might run into some mistakes. Try to debug as I've done. Take care, everyone. See you in the next video. Hopefully, if I'm good, I'll do it tomorrow. If I'm not feeling well, then I'll do it as soon as possible. Thank you so much. Bye bye. Hello, everyone. My name is Abhishek, and welcome back to my channel. Today is day 7 of Terraform Zero to Hero series. And in this video, we will deep dive into the concept of secrets management in Terraform. Secrets management in general is a very, very important concept. Whether it is Terraform, Ansible, CI/CD, or Kubernetes, you need to learn how to implement secrets management. Why? Because using secrets management, you will handle the sensitive information. And as a DevOps engineer, in your day in, day out, you deal with a lot of sensitive information. It can be passwords, API tokens, it can be certificates, or anything that you have to handle. So for that particular reason, in today's video, we will do an end-to-end demonstration using HashiCorp Vault. So HashiCorp Vault is one of the most popular choice for secret management, and you can integrate HashiCorp Vault with Ansible, Terraform, CI/CD, or even with Kubernetes. So that's why the first half part of this video will be helpful with respect to any of these concepts, but not just installation and configuration. In today's video, we will also learn how to integrate Terraform with HashiCorp Vault and use the secrets from HashiCorp Vault. So please watch it till the end, because this is going to be really, really useful. So I've already created the folder for day 7, and whatever we learned today with respect to commands, with respect to the concept and the Terraform project that we are going to create, everything, all the manifests are already available in the GitHub repository. And by the time I upload this video, you will see these things live. So you can watch the video and practice parallelly as well. And with respect to HashiCorp Vault, it is slightly complicated with respect to the number of integrations that it support. So don't get overwhelmed, and let's restrict our HashiCorp Vault demo to this particular video so that you don't get confused. Because in HashiCorp Vault, you can use information related to Kubernetes, you can use storing SSH related information. But what we will try to do is we will focus more on the I'll tell you which parts of HashiCorp Vault we will focus more in today's video. But for now, yeah, just understand that HashiCorp Vault at times can be overwhelming, but I will try to make it as simple as possible. Okay, so let's quickly get started, and we will start firstly with creating a Linux instance. And in that particular Linux instance, we will install the HashiCorp Vault. So let's go to our AWS console. So this is my AWS console, and I'll quickly install Ubuntu machine. So click on the launch instance, and let's give the name called Vault, and select the instance type as Ubuntu. So better select it as Ubuntu, because in today's video, I'm going to show all the commands with respect to Ubuntu. So there might be some changes if you use CentOS or other distributions. That's the reason why. Just if you are not comfortable with any other operating systems or distributions, better restrict yourself to Ubuntu and EC2 instance as a platform. Perfect. So the instance is instantiated, and let's give it a minute for the instance to be available, up and running. And then meanwhile, I'll show you this particular folder. There is a file called Vault Integration, and here I've provided detailed steps even on how to create EC2 instance. And after that, whatever commands that I'm going to execute are from this particular page itself. I mean, I don't want to always go to Google and search for these things. So I've already pasted this, and this will also help you. Perfect. Instance is running. Let's copy the public IP address, and let's get our terminal. So my terminal is here. And now what I will do is I'll just do SSH -i, my key, followed by Ubuntu @ the instance IP address. I think most of you already know this. If not, please check the day 3 video on the AWS DevOps Zero to Hero playlist. If you're new to EC2 or if you want to understand how to create a virtual machine, all of the information is available on day 3 AWS DevOps Zero to Hero playlist. Perfect. Now let's utilize this to make it little easy. What I'll do is I'll take this in a different tab. Okay. And I'll just copy paste it from a different tab so that will be little quicker. Okay, so the first command, what I'll do is I'll just update the app package manager and install GPG. Okay, the reason why I'm doing this is Vault is not available by default as a package in your Ubuntu. So what I'm going to do is I'm going to add the HashiCorp package manager to my Ubuntu. So whenever there is no package available on your Linux machine or your OS distribution, what you need to do, either you will go to Google and download it using the curl command, or if the provider provides any package that is supported by the package manager, so you can add that repository, which will add all the packages of that particular provider. So what I'm going to do is now I'm going to, so a couple of commands that I'm going to execute are with respect to the signature verification. So you don't have to get confused with respect to these things, and these are not mandatory as well. So both these commands are with respect to GPG. And now comes the actual thing where I'm adding the HashiCorp. See, what I'm trying to do is this is the HashiCorp repository, and this HashiCorp repository will be added to the Ubuntu, so that now the package manager, once this is done, you can run command sudo apt install vault, and that would install vault. Before adding this before adding this repository, it will not be able to install the vault instance. As you add a package manager, you need to run sudo apt update. It's a good practice because your repositories get updated. Now this is a main command, sudo apt install vault. Now this will install your vault, and we can verify by just executing the vault command. It should give the usage, how to use vault. It should just print on your terminal. Let's just give it a minute. Vault will not take much time. Perfect. It's done. Now we can just execute this command called vault. Perfect. Now vault is installed. The next thing that you need to do is to start the vault server. Now vault comes in two different variations. One is you can start the production server, or you can start the development server. For proof of concepts and demonstrations, you can use the development server. It has the features that are required. There is no problem in using it. But when you're using in your organization, you need to use the production instance. You need to attach TLS, you need to attach certificates, and you need to create the production grade instance, right? You can consider it as, for learning Kubernetes, for your local purpose, you use Minikube, whereas in your organization, you use EKS or any production grade Kubernetes cluster. Similarly, here we are just starting the Vault development server. So now the Vault development server is started, and what you need to do is just take a new tab. Okay. And in the new tab, just create one more session for this particular EC2 instance. Why? I'll let you know in a second. So again, I'll copy this instance IP address, and I will do SSH -i Ubuntu@IP address. Now, why I've taken a different instance, a different terminal, is because in this particular terminal, I just want to keep my development server running. I can run it as a background process, but I just want to show you if there is any error, or while the demonstration, during the demonstration, if there is some error message or some log message, if I want to show, I can just keep this as a reference. So that's why I'm not running it as a backend process, background process. Now you need to just copy this one and export this in your another terminal. So I missed the hyphen. Perfect. Now you can access your Vault instance. Of course, the caveat is you need to enable your security groups. I think by now all of you know what exactly security groups does. We learned in our AWS course. So by default, security group does not allow any external traffic on the ports. Only the SSH is enabled by default. 996. Okay. So now we are using a different port, different TCP port. This is 8200. So traffic is not allowed. So what you will do is you will go to the security tab, click on the security groups, edit the inbound configuration, and add this particular custom port, custom TCP port 8200. And you can allow any source to access the instance. And as soon as you add it, you can just refresh this page and you will see the Vault user interface. And there are multiple ways to authenticate with Vault, but we don't have all of these enabled right now, right? So if you want to enable LDAP or if you want to enable OIDC, then that's a different integration. If your organization is installing Vault, they can use the OIDC, or if they have any LDAP, they can integrate it with their existing user base. But right now, for the purpose of demonstration, you can go back to the other terminal and you will see a root token here. So just copy paste this root token and you will get the root access to your HashiCorp Vault user interface. So this is how HashiCorp Vault will look like. Let me increase the font size. So this is the user interface, and to your left side, you see a lot of options. What is important for us in today's video is to understand about secret engines, access, and policies. I'll make it very, very simple. Sometimes this concept is complicated. Even if you go to HashiCorp documentation, it's not that well explained, but I'll make it very, very simple for you. So secret engines are nothing but you can consider them as different types of secrets that you can create in HashiCorp Vault. For example, you want to store a Kubernetes secret, okay, a TLS based Kubernetes secret. Then you can use Kubernetes secret engine, and to configure it, you have to provide your Kubernetes cluster details so that you can integrate your Kubernetes cluster. Or let's say you want to store a regular key value pair. What is it? Like a username and password. So you can just use this particular thing called KV secret engine. KV stands for key value pair. And in today's video, let's use a very basic KV, a key value pair, and let's integrate. But the process will remain same for any of these secret engines. Let's say you want to store AWS related authentication information, secret access key ID, and secret access key. You can use the AWS provider, Azure provider, lot of options. But let's go with a very basic KV. And by default, nothing is enabled in HashiCorp Vault. It's a out of the box solution, and there is no secret engine, there is no users, there are no policies. You have to create all of these things. So you just provide a path. This path is basically to mount. So you have installed this HashiCorp Vault, right? This HashiCorp Vault is installed on your EC2 instance. Now you are creating a username and password here. Where will HashiCorp Vault store these things? So it needs a mount. So this is the path where you are telling HashiCorp Vault to mount it. So just tell it as secret itself. Okay. So it will use this particular path to mount or to store all the information related to the user and password that you are creating. And why HashiCorp Vault is very popular is because it does the encryption. As soon as you enter these details here, the key value pair, username and password, it does the encryption. And even at the mount or even on your instance, it will only store the encrypted information, and decrypted information is only available with HashiCorp Vault. You don't have to go to that details. It is very much about the secrets management solution and HashiCorp Vault. But because we are talking about it, I just thought I'll explain. Now click on the enable engine. Sorry, what did it say? Let's just go back. Am I using the right instance? Just give me 1 second. One instance is running. 118, 188, 173.96. Perfect. Okay. There is no problem. There is already a folder called secret. That's what it is complaining. So what I'll do is click on the new engine, click on KV, and let's give a different path. Yeah, let's keep it KV only. There is no problem. And enable the engine. Perfect. Now engine is enabled. That's it. That means now you have just enabled this particular thing where you are telling HashiCorp Vault that I will use this to create key value pairs, but right now you haven't created anything. Now let's create a secret. Name of the secret, let's call it as test secret, and let's say username as username itself, and let's call the password as for example Abhishek. Okay, and let's save it. Now in the HashiCorp Vault, you have created a secret, but nobody has access to it, right? You are the root user, so you have access to it. But if you want to access it through Terraform, or if you want to access it through Ansible, they don't have access. And how can you grant access for Terraform or Ansible? Basically, you need to create a role inside your HashiCorp Vault. It is very similar to the concept of IAM role. In general, when an external entity or any other resource want to access resources or any particular things in your AWS account, what you will do, you will create an IAM role, and for the IAM role, you will grant the policies. Exactly same. Here, you can consider access as your IAM role, and you can consider policy as your IAM policy. In access, again, there are a lot of options. If you click on enable new method, you will see JWT based authentication, OIDC, TLS, username and password. But the most widely used is the app role. App role is very similar to IAM role. So what you can do here, click on app role and just enable this particular method. Now you are telling HashiCorp Vault that I want to use app role based authentication. So I will use Ansible, or I will use Terraform, or I want to use anything, and I will authenticate Terraform or Ansible using this app role mechanism. Got it? So for that purpose, what you need to do, you cannot create any roles through the user interface. It's one of the drawback, or for some reason they don't support through the user interface. So what you need to do is you need to take the CLI itself. It is very simple to support creation of users, creation of roles, but it is not supported through the user interface. So what you need to do is you need to create that using the command line itself. So the first thing that you will do, even before creation of IAM role in AWS, you will firstly create IAM policy, right? Similarly, here I want to create a policy, and I already have the policy here. Okay, so what I'm doing in the policy is I'm just granting access to different folders or different mounts. So KV is a mount, secrets is a mount, secret is a mount. So I've just done it because you can create any particular mount here. You can create the mount as name secrets. You can create mount as name KV, or you can create mount as name secret. So if you don't want, you can just remove these things and keep any one of these things. But I know many people are going to try different things. So that's why I just kept it as is. Enter. So the policy is created. And what this policy is doing, so the name of the policy is Terraform. And now I'm just granting this policy access to all of these particular mount points or the paths, right? So now Terraform has access to secret folder. Terraform has access to the KV folder or the KV path. But there is no role created. We have just created the policy. We have created, let's say, IAM policy. Now we need to create a IAM role, right? So what I'll do is, again, I'll just go to my notes and copy paste this command. So the command is that vault write what is the name of your role, what is the name of your policy, and all of these things are configurable parameters. It's okay even if you ignore them, but you know, these are something related to the session. These are something related to the token and very basic things. So the TTLs. So if you want, you can keep it or you can ignore. Definitely for the purpose of demonstration, it will not fail. But in your organization, you have to read through the HashiCorp documentation and configure each of these parameters according to your requirement. So token policy is very, very important. Whatever the policy that you have created, you are granting to this particular role. If you are not understanding it, just try to compare with AWS concept. So understand that you have created an IAM policy and now we are creating IAM role. And using this particular line, you are attaching the IAM policy with the IAM role. Perfect. Now IAM policy and the IAM role are also attached. And finally, what you need in AWS, your access key ID and secret access key ID. Similarly, even here you have role ID and secret ID. So you can relate this concept with HashiCorp Vault, AWS, so that just change it to Terraform. I think it is wrong in the notes as well. We need to correct it in the GitHub as well. But people who are watching it, if you are practicing along with me, then you can change it. So this is the role ID. We can get this information from the AWS UI, but unfortunately in HashiCorp Vault, we use a lot of CLI. And then you have this final command. Okay, again, I need to change it here to Terraform. Perfect. So I got my secret ID and I got my role ID. You can compare this with your AWS access key and secret access key ID. And these are very, very sensitive. You cannot share it with anyone. Now we can just use both of these things in the Terraform and we can authenticate with HashiCorp Vault and we can retrieve the secrets. So we are almost done. We are only left with writing the Terraform project. So what I'll do is I'll go to my Visual Studio. Yeah, today I'm using my Visual Studio because the GitHub code spaces somehow is not working. I don't know what is the issue. Is it from my side or is it with respect to everyone? If it is not working for you as well, just let me know in the comment section. Not entirely sure and I did not have time to debug. So I thought I'll use my Visual Studio code. So this is an empty folder called day7 and inside this, let's create main.tf. So as usual, we'll start with provider AWS because we will use this secret and what shall we do is we will just use this password as a tag value on your AWS EC2 instance, or you can use it for the S3 bucket. Name of the S3 bucket, you can use the password that is Abhishek. So in my case, I have just stored the password as Abhishek, but usually password can be any sensitive information. Let's say in your organization, there is a project team and they want to keep the name of their S3 bucket secret. Okay. So what you will do is you will go and create a value for them in the HashiCorp Vault so that nobody in your organization will understand except their project team. And you will take that particular key, you will take that particular secret value and you will create that as the name of the S3 bucket, right? So in this case, what I'll do is I will create an EC2 instance and I will use the password that I have stored, right? Abhishek is the value of the password. I'll use it as the tag for the EC2 instance. But you can do anything. You can create Lambda function and use it as the name of the Lambda function. You can use S3 bucket and use it as the name of the S3 bucket, whatever you would like to. Perfect. Provider AWS, let's use the region as US East 1. Now comes the important part. Here, what you need to do is you need to use the provider. The provider is HashiCorp Vault. So just call provider Vault, right? Similar to provider AWS, you have a provider called Vault as well. Now, what you can do with this provider Vault, basically you can create resources in Vault or you can read the resources in Vault using Terraform. So to create resources, you use resource tab, right? Sorry, you use the resource keyword. But what will you do if you want to read the resources? If you want to get some information from AWS or if you want to get some information from HashiCorp Vault, any other provider. So in such cases, you will use a keyword called data. Okay. So to retrieve the information, you will use the keyword called data. to create infrastructure, you will use the keyword called resource. That's it. That's the only difference in Terraform. So to authenticate with Vault, there is a defined syntax. You will get this syntax in the HashiCorp documentation as well, or you can use my GitHub repository and you can copy this information. So there is no rocket science in this, and anyone in the world, they have to use this particular syntax and they have to follow the documentation, because nobody will remember all of these things, right? Why would you remember this provider syntax and what you will get out of it? There is nothing. Even if someone is asking to write this in your interview, you just need to write the skeleton. Nobody would expect you to write this as is and exactly similar. Okay. Provider, Vault, just provide the EC2 instance IP address. Where is it? Perfect. So this is my EC2 instance IP address. So skip shell token is required. Basically, if you don't use this one, then your authentication would fail. It tries to create a lot of shell tokens. So because you are authenticating with token, what you can do is you can skip the shell tokens. And this is a suggested solution and recommended by the HashiCorp documentation itself. This is important, how you want to authenticate with HashiCorp Vault. So like I told you, there are different mechanisms, but what we are using is the app role mechanism. So that's why I said auth app role login as my path. And here I have to give my role ID and the secret ID. Just I'll copy paste it from the terminal. Finally, just copy the secret ID. Right now, till now, let us see. I'm not writing any data block as of now. Okay, I'll just keep the data block commented. I want to verify if my authentication is working fine or not, or the HashiCorp Vault part is correct or not. Okay, so for that, what I'll do is I'll switch to day 7. And here I will run Terraform init. If I have done any mistake till this point, I just want to correct it. I hope I haven't missed anything, but let's see. So it is installing the Vault and it is installing the AWS related provider information. Perfect. The provider is initialized perfectly, but that does not mean your authentication is working fine. It's just the provider initialization is successful. Now you will understand about the authentication and authorization when you try to read the resource, right? Right now, what you have done, you have just initialized the provider, so there will not be any error even if there is authentication related issue. So now what you can do is either go to the Terraform documentation. I'll quickly show you. What I'm trying to do is, you might think that Abhishek, you have everything in the GitHub repository, so you're just copy pasting it, but I can also do it from official documentation. There is no difference. So I'll just go here, search for Terraform Vault. Okay, I know what I want to do. So I'll just go to the documentation. I want to read the KV secret, right? The secret type that we have used is the key value pair secret. So I want to read the KV secret. So to read the resources, you have to go to data sources. To create the resources, you have to go to the resources, right? Example, let's say you want to create S3 bucket. You need to go and search for resources section for S3 bucket. If you want to read something from the S3 bucket, you have to go to the data sources. Just an example. So I'm reading the secret. So I'll go to data sources and here I'll just search for KV. So Vault KV secret 2. And here there is a clear syntax on how to read the data. Just copy it, go to your Visual Studio and paste it. So it's the game of copy paste. I'm not doing anything. You can keep the data name same, but you need to change the mount name and the name. So what is the mount? In my case, the mount is KV, right? And what is the value here? That is, in this case, what is the secret name? What is the secret that we have created? Test secret, right? Let's go and verify. So KV is the path and inside KV, test secret is the name. Perfect. So I have provided the mount and I have provided the name. Now again, I'll just try to verify if the authentication is working fine or not. Now till now, it will not give me, or it will not print the information on the terminal, or it will not even create the EC2 instance and create a tag because we haven't written that particular syntax. But if Terraform execute this block of code, and if Terraform can retrieve this information, my authentication is working fine. And it is very important for me to understand. So what I'll do, Terraform apply. Perfect. It said there is some issue here. Provider vault parse first segment in the URL cannot contain colon. What did I miss here? Should I just give HTTP? Probably. Let's try. Yeah, that is the mistake. You see here, it said apply complete, 0 resources created, changed or destroyed, because we are not using Terraform to create resources. We are using Terraform to read the resource in this particular demo. But my apply is created. That means the HashiCorp Vault and Terraform integration is done. Now let's write the EC2 instance logic. So I will use this particular value from HashiCorp Vault and I'll upload that to the EC2 instance. So I'll just say resource AWS underscore instance. Let's call it as this is not the name of the instance. I mean, this will not be saved as your tag or something. This is just for the reference. If you want to call this EC2 instance within this Terraform project, this is useful. Otherwise, if you're not calling this instance in any of the resource block, then this is of no use. But perfect. Resource AWS instance example. Now let's say AMI as I'm hard coding these details. If you want, you can use variables.tf, tfvars, but I don't want to just extend the demo. So I'll just hard code these things. Okay. We have learned in previous classes how to use variables, variables.tf, modules, everything. Now I want to add it as a tag, right? So for that, what I'll do is tag is nothing but a list of key value pair, right? So here I'll just say name. Sorry. Why is this not working? Perfect. Here I can provide the name. I can actually copy paste it from the HashiCorp documentation as well. And here, okay, I just want to give one tag, whatever we are using, right? I thought I'll give the name to the EC2 instance as well. But I'll just upload the secret so that I can clearly show you that is only one tag, and that tag is the secret and the value, right? So let's call it as secret, and here we will provide the value. What I'm trying to do here, I'm trying to take this particular value, right? I'll take this particular value as the value of the tag of EC2 instance. Like I told you, you can use it for the S3 bucket, you can use it for anything. Once this instance is created, you will understand what I'm doing. So here I'll say data dot. So data dot this particular key dot example, and then you need to take the here. What I'm trying to do is I'm trying to get this particular data and it will give this entire information for me, right? But what I need is only this particular value of the key value pair. So if I just use this particular thing, what will happen is it will return a key value pair for me. Okay. If I just do here, if I just leave it like this, so I'll get this particular thing, and inside I can either use a key value pair or I can just retrieve the information and just get the value. So what I will do is I will copy the data, and inside the data, I'll just use the name that is foo. Why I've copied foo? Because I'm taking it from here. Oh, sorry, it has to be username. Okay. So data dot vault kv secret dot example. And why I'm getting this particular thing? Because if this is not mentioned, you will get this entire information. Okay, you will get this entire key value pair, username followed by the value. But I only need the value of the username, that is this particular thing. So I'm just doing data of username. Now let's try to print this and see. I mean, let's try to execute this and see. Terraform apply. I hope this works. And I hope it will create an EC2 instance with this particular tag. Okay, again, there is an error. It said error making API request with respect to HashiCorp Vault. Okay, let's see what has gone wrong. Invalid secret ID. Did I change anything here? No. Did I change anything here? Why is it trying to authenticate one more time and failing? HTTP app role login. Okay, let's debug. Provider. Invalid secret ID. Address makes sense. And I just added this particular block. And with this particular block, it started failing. So let us see if we messed up something here. Let's run Terraform apply one more time. No. I think with respect to my HashiCorp Vault, something went wrong. Let's refresh the page and see. Okay, let's authenticate one more time. Space. This is my root token. Okay. Let's try it and see. Terraform apply. Okay, something is going wrong. Okay, I just generated a new secret. That is, the step that we have done initially with respect to creation of the these two things, role ID and the secret ID. And let's see if it works. And to be very honest, it shouldn't happen. And I'm inconsistent dependency log file. Okay, maybe the previous action is still there. I'm not sure if there is any action that is going on this particular instance. Yeah, but that's fine. I've just recreated the role ID and the secret ID. And if it works fine, then in your case, you don't have to modify that. So I'm just rerunning the Terraform apply. Invalid syntax. Okay, that's not a problem. The given key does not identify an element in the collection value. Okay, let's see, what did I miss? We can get rid of this one. And here, I think this has to be username, right? So now if the instance is created, the instance should be populated with the tag that has key as username and the value as my particular password that I've stored in the HashiCorp vault. And in this case, the password is Abhishek. I think, yeah, it is working. And I just have recreated the role ID and the secret ID. And if at all you have to do, again, the steps are the same. You don't have to change anything. Or probably because this is a development server, you can also restart the server and re-execute all of the statements. But if you restart the server, you have to run all of the commands. because your password and everything will be deleted. This is just a development server and it does not have any state, right? So if you restart, the existing information is lost. So you have to do right from the starting point, that is creating the secret, adding the mount, creating a authentication mechanism, everything has to be done. Perfect. Now let's go ahead and see on the EC2 instance if this secret is added. Okay, so is this the instance? No, we have created in US East 1, right? So the instance is just created. If you see, the status check is still initializing. And if you go to this particular instance and if you go to the tag section, you will see secret Abhishek is added to the EC2 instance. Now you can try it with S3 bucket as well. It's not a big deal, right? If you want to try it with S3 bucket, all that you need to do is just add one more resource called S3. And here, of course, you have to keep it very, very unique. In this case, the username is a very simple thing, right? It's called Abhishek, and S3 bucket name has to be very unique. You know about that. So what you need to do is just search for resource in the AWS bucket. For S3 bucket, whatever is the resource name, you just have to copy that particular resource name. We can refer the documentation. So how will you do that? Just go for Terraform, and it's actually bucket name, I guess, but just go for AWS. And here you will have the entire documentation. Search for bucket. Where is this S3? So I'm just giving an example. So S3 simple storage, AWS underscore S3 underscore bucket. So you can use this particular syntax, and what you will do here, AWS underscore, sorry, S3 underscore bucket, and inside this, just provide the name of your bucket. I think it goes with, is it with, yeah. So this is your bucket name. So here you can provide this particular value and your bucket will be created. But in this case, this value is not very unique. So it will not be S3 bucket with SP bucket will not be created, and the creation will fail. Either you can go to your HashiCorp vault and update the secret, or you can variabilize this and add new variables to it. Okay, so it's up to you. You just can try this with multiple things. I have just given one example, but the major thing that you have learned today is the integration between Terraform and HashiCorp vault. Please try to do this demo. It is very, very important. And let me know in the comment section, how did you find it? Thank you so much for watching it. Take care, everyone. Bye-bye.